Hello everyone, I am Siddharthan. This video is a complete tutorial on Python data types. As you might know, I'm making a detailed hands-on course on Python programming, and the recent topics that we were discussing were about the different data types that we have in Python. So I wanted to combine all these videos and present this in one single video so that it's easier for you to learn, where we have discussed about the topics such as integers, floating points, strings, list, tuple, set, and dictionary. So if you have watched all those videos separately, you can definitely skip this one. If not, you can watch this so that it's convenient and it's in one place. I'll also provide the GitHub repository that has like all the codes that I've used for all these videos. You can check that out. And for the topics, we have discussed about integers, floating points, strings in detail, and we have also discussed about the operators that goes along with these data types and what is meant by mutable and immutable data types. And finally, we have discussed about the different sequence data types in very much detail. So we started with list, tuple, set, and dictionary. So these are the contents that we will be covering in this particular video, and I'll provide timestamp for different topics, and you can navigate through these different topics of your choice. So I hope you learn from this video and it's helpful to you. So let's get started. So for coding, we will be using Jupyter Notebook as our notebook environment. So let's just start with a very basic data type, integers. So I'll say this as integer values, and integers have a keyword called as int, so they belong to the class of int. So here let's create a variable and call this a and pass in some integer values like 10. So we know that this is a positive integers, and integers would comprise of positive numbers, negative numbers, and 0. So later I can just print this a, and that's going to print 10 here, right? So or maybe I can just put a string before this and say the number is a and run this. So it's going to say the number is 10, right? Now, at some point, if you want to know or if you want to validate what's the data type of a variable is, in this case, the variable is here, right? So if you want to verify this data type, then you can use this keyword type and within this parenthesis pass that variable. So here, basically, I'm checking the type of A or checking what's the data type of A is. And I'll run this cell and that's going to say this is an int. So this is the keyword that we have over here. So this is how you can check data type of a variable in Python. So similarly, we can just consider positive integers, negative integers, and so on. So I'll just consider another example where I say that my int is the variable that I'm creating. Let's say my int 1, which is equal to 10, and let's say that my int 2 is equal to minus 100, a negative number. So here let's try to print these two values and also print what the data type is. So here I'm going to say this is a positive integer, put a colon A, and we have already discussed about f string, which is going to substitute the variables within a longer string. So here I'm going to substitute this with my int 1, and then I'm going to say the type is, here I can say type of my int 1. So basically what we are doing is we are printing this positive integer and mentioning this 10, and also beside that we are mentioning the type of that my int. So similarly I'll just copy this entire thing and replace this positive with negative, and instead of my int here we are going to print the details of my int 2, right? So this is just like printing the integer values, and this is going to say that this is a positive integer 10 which we have printed, and it has detected the type as class of int, and negative integer is minus 100, negative number, and it also belongs to this class int. So now we need to understand what this class int is. So previously we have used this type of a, right? So when you just run this type a, it's going to say it's an integer, but when you put this in a print statement, it would say it is class of int. This is because integer or this particular value is an instance of the class int. So let's discuss about this class and objects in the later part of the course, but just remember that when you just run type a, it's going to say int. When you run print type a, it's going to say that it's class int, which basically means this is an object that belongs to the class integers that we'll be discussing later. But that's all about integers. So now let's look at floating point values in a similar way like this one. So this will be floating point is like nothing but decimal values. So that as the keyword float with lowercase f. So as I hope that you know that Python is case sensitive. So you can just mention this int in Python, so that becomes a keyword, but you can't say int with the uppercase letter. Maybe I'll show this. So when you type an int, so that's going to consider this as a keyword because this is like an inbuilt keyword in Python. But if you use capital I or uppercase int, so that's not going to consider this. So as Python is case sensitive. So similarly for float, the keyword is float with a lowercase f. And here let's consider another example. So let's call this as b, and let's say that 10.5. You can print this b, and then you can check the type of b, run this, and again you can put a print statement, and that's going to say this belong to the class float, right? So floating points are nothing but a decimal values. So this is about it. So the other data type that we can discuss is a complex number. So let me put this as complex number. And for this, the keyword is just complex. So I hope you know what a complex number is, and we all would have studied this in high school math, right? So a complex number has two parts, a real number part and an imaginary part. So let's say that my complex number. So this is a variable I'm creating, and let's say the value is 3 plus 4j. So we call this 4i or 4j or something. So this is the complex number. So this 3 is what we call a real part, and 4j is what we call as an imaginary part. So this j is nothing but, this is the imaginary unit, that's nothing but square root of -1. So you can't do a square root of -1, and that's what we call a imaginary part, and this is the imaginary, number section. And this complex number are kind of used in the lot of fields. It's used in mathematics, engineering, electrical engineering, and so on. So it has like a lot of applications, and in Python we have an inbuilt data type for that as well. So if you want to again check the type and print this and so on, so you can just print this as my complex number, and then we can print this type as well. So now print type of my complex number. So it's going to say, and the other thing is complex number will be enclosed in parentheses when you print it, and it's going to say it belongs to the class complex number. So similarly, you can also have a complex number that is completely imaginary, that doesn't have an imaginary part. So let's say that has only 4j, so it's going to say 4j and it belongs to the class complex. So this is how you can create complex numbers in Python. So the next basic data types that we are going to discuss is a string. So this probably would have worked on it a bit in our previous videos as well. Strings are nothing but, it can be a character, can be a character, nothing but an alphabet, or it can be a word, or it can be a sentence, or it can even be a paragraph. All these text data is what we call as string. Okay, and let's say that I'm creating this as my string, and all the string values should be enclosed in quotes, because variables are also created by this letters, right, alphabets, right? So distinguish that all the string values should be enclosed in double quotes or single quotes. So maybe I'll call this as my string 1, and this can be, let's say, hello, and let's say this is my string 2, and here I'll say Python. So this is what about string. So you can either enclose the string in double quotes, a starting double quote and a ending double quote, or you can use single quote in both those places. So that's valid. So you can use either double quotes or single quotes, and later you can print this my string 1. So you should put a underscore here and print this my string 2. So that's going to print hello Python. So similarly you can check the data type as well. So here I'll just put a type keyword before this, includes this in parenthesis. So it should say class string. So str is the keyword that we have in Python for strings. So I'll just put this as string, and in bracket I'll mention the keyword that is str. Okay, so these are the string keywords, and we have also seen how we can use f strings in order to substitute some values. So let's say that we have this a is equal to Python, and then we have b is equal to hello, and within this braces we can say a. So that variable is going to be substituted, but you need to put a f here. So it's what it's going to do is, so it says hello, and it replaces whatever is present within this curly braces. So this value or the a that we are mentioning is nothing but the variable that we have created. So when I finally print this B, that's going to say allow Python. So it's not like you can use F strings only in prints. You can use this F string outside this print statement is it as well. And this is something that we kind of use a lot. And string is like a very important data type, and we do a lot of operations on that as well, like slicing and how you can like chunk a part of the string and so on. So there are like a lot of use cases on that. Maybe let's discuss that in a later video, but for now the basic string is enough. So we have the string that is represented by the keyword str, and then we can represent this using f strings as well, using the letter f before the string that we have. And the next basic data type that we have is boolean. So boolean data type is nothing but just true and false. So true and false. So these two words are the boolean values, but they should start with uppercase letters. So true and false with uppercase T and uppercase F. So if you change it, it won't work. As I said, Python is a case sensitive programming language. So here I'll say that yes, Sunny is equal to true. So as you can see, when I type in true, this color changed to green. But if I put a lowercase t, it's going to be in black as usual. So this is how we can know that this is a keyword. So here I can just say print uh, is it Sunny, and let's say that let's just replace this with the variable that we have created is Sunny, which has the values as type as true, right? So let's run this. That's going to say is it Sunny? True, because we have assigned the value true to this variable called as is Sunny. If you want to look at what the data type is, you can just pass the variable here is Sunny. So that's going to say boolean value. So it's not like you have to pass only the variables, you can just pass the values itself. So I can say type of true. So that's going to say it's a boolean value. Similarly, you can just check the type of integers not by passing the variable, but you can pass the actual integer value itself, and it can say integers. So similarly, false is also another boolean. So you can say, let's say b is equal to false. So here I'm assigning b the boolean value false, and then just print b and the type of b. So when I use a print with and type, we know that it's going to say class bool. Okay, so those are boolean values which has only two values, true and false. So similar to this, we have another type of value called as none type. Okay, and this is represented by none. So none basically represents there is no value in that variable. So let's say that my none variable is equal to none. So none starts with an uppercase n. So when I print this, uh, let's say f of none type example, and I can put a curly braces as this is a f string, and just put this my none variable here, and that's going to say none type example is none, or you can just like print this one itself. So that's going to say none. And if you want to check the type, copy this entire thing, put it here, and say type. It's going to say class none type. So it belongs to the class none type, and it is represented by none. So here true and false are represented by bool, right? So similarly, this none is represented by the class none type. And this none is basically used in a lot of conditional statements. Like we would have if and else condition, where we would check whether a condition is satisfied or not, again, which we'll discuss later about this if and else. But remember that in those cases we use this none. So sometimes we want to make sure that a variable doesn't have any data in it, it is a none type. In those cases we run a particular part of the code. So in those places this none type is like used a lot. So it also like has a lot of usages in Python. So these are all the very basic data types that we have in Python. So we have integer values, and then we have the floating point values. Again, it can have like any decimal places. Here we have just taken one value, and then we have discussed about this complex number which has a real part and imaginary part, or even it can have like a imaginary part alone, and then just a basic version of string, boolean value, and none type values. These are the basic data types. As I said, in the subsequent videos let's discuss about the conversions that we can do. So how you can convert an integer value to float, or a float value to an integer, and how to convert an integer to a string and so on, and then we will discuss about the different operations that we can do on these numerical data types. Later we can discuss about the string operations and also the other data types that we have, such as list, which is similar to a array that has like multiple values. So we have list, set, dictionaries, and tuples. So we will discuss about that. So I hope everyone understood what we have done today in this particular video. So that is all from my side, and I'll see you in the next upload. Thanks for watching. Hello everyone, I am Siddharthan. This is the 11th topic in our complete Python course where we are going to discuss about casting in Python. Casting is basically used in order to convert one data type to another. In the previous section, we have discussed some of the basic data types such as integers, floating points, strings, etc. So in this video, let's understand how we can do this casting so that we can convert one data type to the another. So this will be the agenda for today's video, and let's get started. So we will be doing our coding part in Jupyter Notebook, but you can try Google Collaboratory or other IDE as well of your choice. So here I've given a definition of what casting is. So in Python, casting refers to converting one data type into another. It allows you to control how data is interpreted and ensures compatibility between operations that require specific data types. So this first sentence I've explained you that it's basically used for data type conversion. And in the next part, what we have basically said here is, so some operation needs to be done on certain data types. Let's say that if we want to add two numbers, those two numbers should be integers or floating point numbers. But if those numbers are in the form of string data types, then we cannot add that, right? So these are some of the aspects where we have to make sure that the data types are compatible for that operation. And in some cases, we may get the input in one format and we may have to convert that into a different format. So these are some of the usage scenarios where we will be using casting, and this is kind of a basic stuff that we use like often. So that's about casting, and now let's get into this hands-on part. So apart from this integer, floating points and other data types, we also have this list, tuples and so on. So that we will be discussing later, but for now let's just focus on this casting only for those data types that we have discussed before: integers, floating points, strings and booleans. That's what we are going to see today. So first I'll explain you about integer casting. So here we are going to convert different data types to integer values. So here let's say that we have the number 3.9. So we know that 3.9 is a floating point, right? It's a decimal value. So let's say that we are checking the type of this 3.9 using this type keyword, which again we have already discussed. So when I run this, it's going to say it is a floating point number, right? So it's a float value, decimal value. So if you want to convert this to an integer, you can say x is equal to, so this is the variable in which I'm going to store the converted integer value that I'm seeing here. So here I can say int of 3.9. So this int keyword that we have, which is an inbuilt keyword in Python, it's going to take in this 3.9 value and it's going to convert this float value to an integer value. So this is to, I'll put a comment here saying that this is float to integer. And then once we have done this conversion, you can print this x value. So here you're seeing that this 3.9 has been converted to a float, and you can also check this type of x again. So now it says the type is integer. So previously the 3.9 was a float, and later we have converted it to an integer. The main thing to note here is when we convert a float to an integer, it won't round it. So if you round this value, right, so 3.9 should be rounded to 4.9, but that won't be the case here. When you're just casting, this decimal value will be just removed. Even it can be 3.99. Even though in that case it won't round it, it will just like remove all the decimal values and keep only the integer value. So there is a different way for rounding, but let's discuss that like after a couple of examples here. So this is for floating point, right? So similarly, let's just like put all these things together. Let's say that x is equal to 4.5 and y is equal to integer of, let's say, x. So here we are assigning this float value to this x and later converting this floating point value x to integer and storing it in this variable y. And then we can print this y, also print the type of y. Okay, so it prints 4. So this 4.5 floating point has been converted to an integer value, and we also print the type as int. So we put this type in a print statement. So it says class, which basically tells us it's an integer object. So that's how you can do this conversion. But what if you want to, round a value, round a decimal value to an integer? So not an integer, but just like rounding of values. So for that, let's say that a is equal to round take some number, let's say 5.678. So I want this to be rounded to two decimal places. So I can mention that 2 here, and then I can print this A, and also I can print this type of A. Okay, so this 5.678 has been rounded off to 5.68, and we now only have two decimal places, and this is a float. So when you do this round, it won't convert it to an integer, even if you have, like, let's say you're saying that I don't want any decimal values. That means it should have only 5, but when you do this rounding, it would say 6.0. So this 5.67 has been rounded off to 6, but we have this dot 0 here. So you can use round, but it would only convert this to an integer. But what if, let's say, you want to round it and convert it to an integer? So in those cases, you can just do these two operations together. So I can just say int of round, let's say 10.9. So this 10.9 has to be rounded to 11. So here I can say 10.9 comma, let's say 0. I don't want any decimal value, so this entire thing has to be rounded off. And then I can print this A, and then I can also print this type of A. Let's see what's the output that we are getting. So now it says integer and the value is 11. So what basically happens here is, first we round this 10.9 to 0 decimal places. That means it will basically be converted into 11.0, and then this 11.0 we send this to an integer, and then we would get the final value as 11. So those are the two things happening. So first what would happen is, let me put this in the comment. So this 10.9 would be converted into 11.0, and then using this integer keyword that we have used, so we would convert this 11.0 to 11. So this integer conversion casting operation happens. Is this is how you can round a decimal value and make sure that it is in the integer format. So this is like another use case. So we have discussed how we can convert a floating point to an integer. Now let's see how we can convert a string to an integer. Let's say that we have the variable as z, and here we are going to convert string value of, let's say, 40 to an integer. So here I can print my z, and then here I can print the type of z. So this is string to integer. So this is a number, but notice that we are using this within a double quote, so this will be considered as a string. So even though you use a number, if you put that in double quotes, that will be considered as a string. Or in other words, whatever is present with a starting double quotes and ending double quotes, that is considered as a string, even though it is a number. So when I run this, I would get this value as 40 integer. But if you check this type of double quotes 40, it would say it is a string. So this is how it would have previously been. So first it was string, and this string has been converted into an integer using this int keyword. So the next thing that we can discuss is float casting. So here we have seen how we can convert other data types to integers. Now let's see how we can convert integers or string to floating point values. So the second thing is float casting. So let's say that x is equal to float of 10. So we know that 10 is an integer value, right? So this 10 is going to be converted into a float value or a decimal value. So here I can say integer to float, and then I can print this x, also print the type of x. So it says 10.0. So this integer value has been converted into a float value. So the next example, similar example, I'll copy this entire thing, put this here. So now we are going to convert a string to a float. So in this case, let's say that we have some string convertible value, like let's say 40.7, but it's in the string as we have this inside double quotes. So now let's run this. So this 40.7 string has been converted into a float value of the decimal value. So this is how you can convert a string value to integer value to a float value, and a string value to a float value. So now let's discuss about string casting. So similarly, how you can convert integer or float to string. So it's like pretty similar stuff, and all these are like keywords in Python. As you can see, those are like highlighted in green color. So int, even this round is like an inbuilt keyword that we have in Python that we can use to round decimal values. So the next thing is string casting. So this is the third example. So here let's say that x is equal to 10, which is an integer. So that we are going to convert into a string. So use str keyword, print this x and also the type of x. So this is going to be integer to string. Oh, sorry. So this should be print. So we have 10 integer, it is in the form of string. So here you may think that I don't know how to distinguish this string and integer. You can just say the variable name. So you shouldn't put this within a print statement, but just like put this within a cell without any print statement, and this works only in the case of like Jupyter notebooks. It's like better in this case. So when you put your x here and run this, your 10 will be in single quotes. But if it's an integer value, right? So if I have let's say y is equal to 10, which is an integer, if I put this y here, we won't see any quotes here. So this is how you can look in the output of whether a particular variable is a string or an integer. So whenever there is quotes, that means it's in the form of a string. Or you can also use this type keyword that we have. Okay. So next, let's see how we can convert booleans into strings. So we know that boolean basically has two values. One is true and the other one is false. So let's say that boolean to string. So for boolean we have to say true or false, where the t or the f should be in uppercase letter. Okay, so when you run this, it says it belongs to class string. So this was a boolean before, so later this has been converted to a string, so we are printing it and then checking the type. But if you just check the type of this true directly, so it would say that it is a bool. That means it is a boolean class. So this again can be done for false as well, as it's like just similar to true. Put this f in uppercase, so we get this as a string. So this boolean has been converted into a string. The next example that we can discuss is how you can convert other data types to boolean values, and this is like, I would say this is an interesting and like slightly different from what we have discussed so far. So this is the fourth example. This is boolean casting. So let's say that x is equal to bool of 0 and print x and print type of x. So whenever you use this bool keyword for this boolean conversion, if the value is 0, that's going to be converted into false. So let me put this in the comments. So this converts integer 0 to false. Okay, but if you have the value as 1, this is going to be converted into true. So 0 means false and 1 means true in the case of boolean conversion or boolean casting. So here I'll just like replace the 0 with 1. Okay, so we get the value as true. And now let's see how we can convert string to a boolean. So let's say that z is equal to bool of null. So here we basically don't have anything. So I just have this starting double quotes and ending double quotes. So this is what we call as an empty string or null string. So this null string is kind of used a lot when we want to initialize a particular variable but don't want to put any values. So like let's say we have the z value, so we initialize with this null string and later in our code we would like replace that with some other value that we create dynamically. So this is what we call as a null string, where you create this with either two single quotes without any space. Even if you put a space, that's not a null string. So there shouldn't be anything. It contains only like opening quotes and the ending quotes. It can be single quotes, or it can be like opening and closing of double quotes. So both these are possible. So when you convert a null string to a boolean, let's see what's the output that we are getting. So here we would get this as, I'm checking the type of z, so it's going to say it's a false. But when you consider a non-empty string, that string can be anything. That string have like any text. So non-empty string is going to give you true, whereas the null string would give you false. Okay. So if I have something, right, so let's say that we have the text as Python, so that's going to say true, even if you have this value as true. So this is not boolean right now because we have this in code, so this is still a string, so that's going to say true. But another interesting thing is that even if you put false, it's going to say true. That's because it wouldn't look at whether the value is true or false, or it's name of a person, name of a word or something. So it won't look at it at all. all the boolean conversion knows is if it is an empty string, convert it to false. If it is a non-empty string, that means if it contains some text in it, then convert it to true, even if it is a false or like any word. So that's how you can remember this. So null strings to false and non-empty strings to true. Okay, so the what's the text within that is like kind of like it's not important. So next, let's see how we can do complex casting. So complex numbers is other data type that we have discussed, right? So let's see that. This is the fifth one, complex numbers casting. So let's maybe consider multiple examples. I will say that x is equal to complex of I'll just consider an integer value, let's say 6, and y is equal to complex of, let's consider a floating point value of, let's say 8.9, and z is equal to complex of this we are going to convert it from a string value, let's say 2 plus 4j. Okay, so here in the first step we are converting integer to a complex value. The next step we are converting a float. So first is integer to complex, next is float to complex, next one is string to complex. Let's run this and also print all these things together. Print x. I'll just copy this and paste it two other times and replace this x with y and z, and we get the complex value as 6 plus 0j, 8.9 plus 0j, 2 plus 4j. This is because these values doesn't have any imaginary part, so we just like use 0j as the imaginary value. And if you want to check the type, you can just say print type of xyz or like any values basically. So the class is complex, and this complex is the keyword that you can use in order to convert one data type to a complex number. So these are all some of the Python casting examples. So we have seen about how you can cast integer values, and then we have also seen how you can round the values and then convert it to an integer using casting. And then we have seen string casting, boolean casting, and finally complex number casting. So now let's discuss like maybe a couple of usage scenarios where we actually kind of use this casting. So let me make this as a text cell and say usage scenarios. So for this, first let's consider the input statements. Okay. So this input statements we have discussed already, but let's discuss that in terms of casting, use. So let's say that I have a variable called as user input, which is something that I'm going to get from the user. So here I'll say, you know, open this double quotes and say enter your age. So we have already discussed that when you use this input keyword or the input function, it's going to ask the user for some value, right? And once they have given this value, we are going to print this, sorry. So we are going to print the user input and also their data type. So print type of user input. So let's run this, and this will prompt the user to enter some value. Let's say that I give the value as 40 as the age, and press enter. So it's going to say 40 string. So the key thing to note here is, even though the user entered value is a number, a numerical value, it would be considered as only as a string value. So it won't automatically detect whether it is an integer value or a floating point value or something. So it will always consider whatever values that is given by the user. So those things will be considered as a string value. So in order to do this conversion, we would use this int outside this input. So I would say int and inputs. I would wrap this input within this int keyword, int function. So that's going to, once the user has given a particular value, that's going to convert it into an integer value. So when I run this, the user can give the value as 40 and press enter. But now this has been converted into an integer using this int function. So this may not work for every scenarios. If the user is not, they are giving something that's not acceptable, right? Let's say that I'm putting my name here. So that's going to create a value error because this word cannot be converted into an integer. So in the input statements also we have seen how we can validate this input. Maybe you can refer to that, but in general we should put only like, let's say, numerical values. I'm putting this as 50 and this would be converted into an integer. So similarly you can use this for floating point values as well. So instead of this int, use this as float, and let's say here we are saying enter your, let's say, weight or something in kg. So when I run this, let's say they are giving the value as 75.5 or something, and press enter. So it says it's a float. So this is how you can get input from the user and convert it to a floating point value. So this is like one such scenario of where you can use this the data type casting in Python. The other scenario, maybe the last one that we can discuss is, let me put this, is string concatenation, which is also something that we often use. So the next scenario is string casting. And let's consider an example. Let's say that age is equal to 40, and I want to, let's say, create a message saying that message is equal to I am, put a space here. We know that we can concatenate string using this plus symbol, right? Age plus space years old. So what this should say is this should insert this age value along with these other things, and print that I am 40 years old. So that's what this should say, and we are printing this message. So when you run this, it's going to throw an error because this is an integer value and you cannot add integer value to the string values. So in these cases, this is what we mentioned when we said that, you know, uh, we have to maintain compatibility in order to perform some operation. So that's the reason. So in this case, instead of saying just age, I can convert this to a string here and run this. Sorry, message is not defined. Okay, let's run this, and it says I'm 40 years old. But if you check the type of a, it's still an integer. So we are not changing the variables type. We're just like converting that and using it here, but the original variable is not changed. So that's something that you can remember. So the age is still an integer value, but while concatenating this with this message, we are converting this to converting this to a string value and concatenating this. So similarly, if you want to do some addition operations, right? So let's say that a is equal to 5 and b is equal to, let's say, 10, but the 10, it's in an integer format, and c is basically the addition of two things. So when you say a plus b and print c, that's going to throw an error because one is integer and the other one is string. So what you can do is, in this case, when you say c is equal to a plus b, this a has to be converted into an integer. So this is converted into an integer that says 15. But what if you convert b into a string? Instead of converting this a into an integer, we are going to have both these as strings. So think about this. So when I do this string of b, it's going to concatenate it, or in other words, it's going to join these two things. So that's how the plus symbol works differently. So this is what we call as addition operators, and we will be discussing about that when we discuss about this operators in Python. So this plus symbol is basically used to add two values when it's an integer value or a floating point value, but when two variables or the two values are strings, it's just going to join those two words, or join those two strings. So here how this would be is, this would look something like this, or you can just perform the similar thing by typing this in Python. So let's say that 5, which is in double quotes, plus 10, which is also in double quotes. When you do this, this would just like give you 510, which basically combines these two values that we have. So that's the reasons, and this is how you can cast this one integer into a variable and you can work on it. So that is all I wanted to discuss for today in this particular video. So I hope that you understood all the things that we have discussed. So these are like pretty fundamental stuff, but we kind of use this often. We use this like a lot. So try these codes and let me know if you have any doubts on this. So that is all from my side, and I'll see you in the next upload. Thanks for watching. Hello everyone, I am Siddharthan. This is the 12th video in our complete Python course where we will be discussing about strings in Python. The previous video was about the different basic data types that we have in Python, such as integers, floats, strings, boolean, etc. But there is more to strings that we need to discuss. So in this video, let's understand what are all the different ways that we can use strings and how you can assign strings, and also what are all the different operations that can be performed on the strings. So this will be the agenda for today's video, and let's get started. So here I'll be doing my coding part in Jupyter Notebook. So you can do this either in Jupyter or Colab or even your PyCharm or VS Code. So here I've just written a simple statement about string in the text cell that says a string is a sequence of characters enclosed within single quotes or double quotes. So the single quotes or double quotes is the main thing here. So whenever you put something in either single quotes or double quotes, that would be considered as string in Python. It can be a combination of alphabets, or it can be a combination of alphabets and numbers, or it can be just numbers that's enclosed within quotes or double quotes. So we consider as that as a string. So let's start with a very basic example. So for that, I'll just convert this code cell into a text cell. So either you can do that by clicking somewhere outside the square brackets, press M. So this would convert this into a text cell instead of a code cell. If you press Y, that would convert this back to a code cell. Or you can select the cell, go to this drop down and select markdown. So now this would become a text cell. So here I'm going to say this as basic string examples. So let's consider, or let's start with simple examples. Let's say that name is equal to Python. So here I'm creating a variable called as name and assigning it the string called as Python. As you can see, I've enclosed this word Python in double quote. So this would be considered as a string. And then I'll create another variable called as language is equal to programming. If you notice, this programming word is present within single quotes. So previously this name value is present in double quotes, whereas the variable language we are using single quotes, but this doesn't make any change. Both these things represent string. So later you can print this strings. So I'm printing this using this variable. So here I'm going to say print language and run this. So it would say Python programming. So this is how you can assign string values to variables. So it's not only for alphabets, but you can also do this for numerical values as well. So let me create a variable called as num, and instead of saying 5, I'm just going to say 5 but within double quotes or single quotes, and then print this 5 by saying print num. So this would print 5, but the thing is this is not similar to saying num is equal to, let's say, num int is equal to 5, print num int. So in this case, right, so this num int, you can see the output is like the same in both the cases, but in this case this is an integer because we didn't put this within double quotes or single quotes. In this case we just like represented the number, but in the case of the previous num variable we have mentioned this within double quotes. So this would be considered as a string, whereas in this case this is considered as an integer. If you want to understand the data type, you can just simply say print type of num. This would say this belongs to the class string or the object string. So this num variable, if you do the same thing but for this variable num int, this is going to say it belongs to the object integer because we didn't put this in double quotes or single quotes. So this thing is same for float as well. If you put a float value or a decimal value without quotes, then it is considered as a float data point. But if you enclose those float value within double quotes or single quotes, then it's considered as a string. So this is like a very basic example of how you can assign string values to a variable, right? And the next example that we see is about multi-line string. So I'll create a comment here and say this as multi-line string. Okay, and let's work on this. And maybe before this you can also check the type of this variable as well. So you can just say type or print type, both works. If you just say type, it won't print you this class thing. So here I'll say name, type of name. So I'm checking what's the data type of this variable name. So it says string, str represents string. And if you put a print statement, it would say class of string. So nothing much complex about it. So now let's see how we can create strings in multiple lines. So here we have just like single word, but what if we have a statement, or what if we have multiple statements in multiple line? In that case, what we can do is just say, let's say a is the string that we are considering, and here or the variable in which we are going to store the string. You can either use 3 double quotes or 3 single quotes to enclose this. So let's say that I'm creating 3 single quotes, so it's going to create another closing quotes. So these first 3 are starting double quotes, these 3 are like ending quotes. So whatever the string should be present like within this particular space. And the other thing about Jupyter is like when you type a quote, the closing quote is also automatically typed. When you open a parenthesis, it's automatically closed, but you need to enable that from the settings and choose this auto close brackets. If you this auto close brackets is not enabled, then you have to manually open and close your parentheses or your quotes. So that's another thing that you can remember. So here I'll create like 3 sets of double quotes, and here I'll say I love programming, right? And I'm going to press enter. This is going to go to the next line, and it's going to say Python is my favorite language. And maybe next like some random statements, like let's say machine learning uses Python. Let's say that this is the multi-line string that we have. So here, as you can see, instead of 1 double quote or 1 single quote, we have used 3 double quotes at the start and 3 double quotes at the end. So this is how you can write multiple line strings, and then you can just print this a and then you can also print the type of a. So the result is also in multi-line, as you can see. So the type is string, but this won't work if you just put a single quote, because when you put a single quote here, right, so that's only for this particular line, so it won't consider the next line at all. So whenever you're using single quote, that's only for like single line statements like this, but you cannot use that for multiple lines. So instead you can just use three double quotes or three single quotes. This can also be done with single quotes. I'll show you this to you. So here we have three starting single quotes, but it should again end with single quotes only. You shouldn't start something with single quotes and end it with double quotes like this. So this should also be single quotes, the ending one. So similarly in this case as well, right? So when you start with a double quote, it should end with a double quote as well. When you start with a single quote, it should also end with a single quote as well. So that's another critical thing. So this is the same multi-line string, nothing different about the value there. Only difference is that here we are using a single quote combination. So now I'll run this and it would just print the same thing, and here again you can check the type and it's going to say it is also string. So that's how you can work with this simple string statements. So the next concept that we are going to discuss is how you can access individual string values. So let's say that maybe I'll explain this to you. So here I'll create a text cell and say accessing string characters. Okay, so this is the next thing that we are going to discuss. And here I'll say, let's say text is the variable that we are creating, and in this text let's have the value as Python. Okay, so now I'll run this. So now this variable has the value of Python, and we are going to access the individual letters in this text. So here I can say print of text of 0. So when I say text of 0, it's going to print P. And when I do the same thing but change this value to 1, it's going to print Y. So what happens here is, this is what we call as indexing. I'll maybe create another text cell and do this. So basically Python uses zero based indexing. So that means you start counting with 0, not with 1. So you don't start counting like 1 2 3. So you start with 0 1 2 3 and so on. So what would happen is, if you consider this word Python, right? So when I say Python, this is for the programming language, but here we have considered the variable value as Python. So what happens is, in this case, index 0 of Python would be the first letter, that is P. Okay, and index 1 would be the second letter Y, and so on. So this process kind of continues and so on. So this is a, you can individually access these individual characters or letters. So P would be my 0 index, Y will be my index number 1, T will be my index number 2, and so on. So this is how you can access these individual values like this. So we have text of 0, that means index 0, which represents this P, and text of 1, this is what we have, and so on. So this is how you can access the individual characters, and then you can also store this as well. So let's say that I'm creating, let's say, a variable called as car for character, and say that text of let's say 1. So text of 1 is nothing but Y, as we know, and later I'll print this character. So it would print this way. So similarly you can access a particular character of a string, and then you can assign it to a different variable as well. Or if you want to print the individual letters, you can use a for loop as well. So I can say for let's say a character, something like, maybe let's do this as for letter in text. That means like for individual letters in text, print that letter. So it's going to say Python. So what happens here is, again we will discuss about for loop later. I'll just like explain it to you in a simple way. So for when I say for letter in text, and the purpose of for loop is to repeat a particular task again and again for a set number of times. So when I say print letter, it's going to print one letter at a time. So when the for loop runs for the first time, this letter takes the first letter of text. So text is nothing but Python, right? So when the for loop runs for the first time, it's like saying letter is equal to P, just similar to this. So letter is equal to P, and then we are printing that letter. In the next iteration of this for loop, letter would take the value Y, and then we would print this y and so on. So this is how you can access the individual characters of this string individually and print the individual letters using a for loop. Just some simple examples. So in this case, the iterator is a text. It's not some numbers, but we are iterating it over the text letters that we have in this variable called as text. So that is like one example. And the next concept that we'll be discussing is about string slicing. So this is another important concept, as we would be using this a lot in a lot of places, like not specifically, but in general, in some of the minor cases, we would use this string slicing a lot. So let's say that we have a text called as, again, these variables, these text values can be multi-word strings as well, even multi-line string as we have discussed. So here I'll just say hello, comma, world, and put a exclamatory mark here. So this is the string value that we have, hello comma world. Okay, let's run this. And now let's say that you want to count how many how many characters are there, or how many elements are there in this string. So for that you can simply say for len, and within parenthesis pass the variable text. So len basically stands for length. So here we are trying to find the length of this text called as hello world. So when I run this, it's going to say 13. So that means there are 13 characters here. So h is my first character, second character, and so on. So if you count, you should even count this comma, and even you should count the space as well. So even space is considered as a character. So you shouldn't like leave out these things. So if you have this hello, right? So here we have like totally 5 letters, and then comma is sixth one, space is 7, this is 8, 9, 10, 11, 12, and this is the 13th one. So totally we have 13 letters here, right? If you count with indexing, as I've told you, indexing starts from 0. So this would be my index 0, this would be my index 1, 2, 3, and so on. As indexing started with 0, this won't be index 13, but this will be index 12. As we have started with 0, when you count until 2, you would totally have like 13 characters. So this would start with an index of 0 and it would end with an index of 12. So that's something that you can remember. So here we have the length of 13. So now we can slice the string to print individual substrings of this overall string. So let's see how we can do that. So I can say print text, which is the variable that has the string value, and I can say 0 and 5. So this would start with the index 0 and print whatever is between this 5, but it won't include this 5. I'll explain this to you. So when I run this, we have hello, right? If you consider the index, that's going to look something like this. So h would have the index of 0, e would have the index of 1, and let me maybe first like type this thing. So we have hello, and then we have a comma, and then we have a space here. So let me just mention space as just space, an empty space is there, and then we would have let's say w, o, r, l, and d. So these are all the different letters that we have, and this would have the value as 2, and this would have the value as 3 index value. So this would be 4, 5. Space would take the index of 6, and this would take the index 7, 8, 9, and 10, 11, and then we have exclamatory mark that takes the index 12. So let me just put a space so that it comes in a different line. So this is critical, so that's why I'm trying to spend a lot of time here. So if you understand this indexing, then you can understand like all the slicing that we are going to do. So totally there are like 13 elements here. So the indexing starts with 0. So when you say text of 0, it's going to print you h. When you say text of 1, it's going to print e, hello, and so on. And then we have this 5 for comma, 6 for space, 7, and so on. So now let's say that I want to print 0 colon 5. So now it's going to start with h0 and print all the way up to this. So when you have this 5, so this first number index value would be included and this last number won't be included. So that's very important. So what would happen is you would print whatever is between, or whatever the values are there between 0, 1, 2, and 3. So and 4. even, yeah. So because we totally have like 5 values, right, this 5 won't be included, so this will be excluded. So when you say 0 colon 5, that means it represents the values from index 0, 1, 2, 3 and 4. It's very important to note that 5 won't be included at all here. So when you look at the string values here, we have 0, we have h1, we have e2, again l and so on, and until 4 we have this o, right. Fifth is comma, but if you see here, the comma is not included here, so that what happens. Now if you print this 0 colon 6, now what happens is you would have the values that belongs to these indices, right. So we have 0, 1, 2, 3 and 4. In this case, 5 would be included, as 6 is the last number, but 6 won't be included at all. So now when you run this, you would get the value from allo and comma. So those are the things that will be printed here. So we have allo and comma. So this is how slicing works in Python, and the indexing as well works. So you can iterate over this a specific part of the string where this start index will be included, this ending index won't be included. So that's how you can remember that. So there is another way of saying this. I can say print text, and instead of saying 0 colon 6, you can just say colon 6. So that's going to print from the first character, right. So this is the same way of saying text 0 colon 6, or just saying colon 6. So when there is no number there, it's considered that there is a 0 there. So you can just do this one by, instead of like mentioning 0, you can just say colon and 6. So that's one way. And the other one that we can maybe try is, like, let's say when I say print 0 colon 6 again here, so we know that it's going to print from h2 hello, right. But if I just say text 1 colon 6, so that would have the values that has the index from 1, 2, 3, 4 and 5. Again, this 1 would be included, 6 won't be included at all. So instead of saying 0 colon 6, I have from 1, 2, 3, 4 and 5. So what happens is, this would start from this e, print all the way up to this space, right, because we are not starting with 0, but we are starting with 1 in this case. So when I run this, I would get this ELLO and comma, which is nothing but 1, 2, 3, 4 and 5, as we have not included this 0. So this is another example. And if you want to print this entire string, right, so what you have to do is, you can just say text 0 colon, you shouldn't say 0 colon 12, because when you say 0 colon 12, this is the 12th index, so this would be excluded, right. So you will see until like the letter D, so this would look like hello world. But if you want to print the entire string, you have to say like the last index plus 1. So the last index is 12, so you have to say 13, because if you put 12, this 12th index value, that is exclamatory mark, will be ignored here. So you have to say 0 colon 13. So this would print the entire string that says hello comma world. Or you can just remember that if you want to print the entire string value, just mention the length of the string. So here we have already found the length of the string. So length is different from index. Length basically counts, right, how many values are there. Again, in this case, in the case of this counting that we do here, 0 doesn't come as index. So this just tells you how many values are there, or how many characters are there. So totally this is 13 characters, but when you consider as index, we start with 0, right. So when you want to print the entire string, just mention 0 colon 13, or the length of the string, right. Or the other way would be to just say 0 print 0 colon. So instead of saying 13, I can say length of text, because it say that I don't want to count how many letters are there in this text. I directly want to print all those things. So I can just say text of 0 colon length of text. So this is like other way. And the other thing that we can try is, you can just say text 0 colon without any number. So if you don't mention any number, it's again similar to saying like length of entire text, or I want to print the entire text. So the value in this case would be 13, just similar to what we have seen here. When you don't have any value here, so here it's considered as 0, but when you don't have any value here, that's like max of the length of the string. In this case, it's going to consider the value as 13. So this is how the string slicing works here. And like there are like other variations that you can try this out. So I can say text of 7, so that's going to start from 7th index, and my 7th index is going to be my W, and it would include all the way up to this exclamatory mark, right, because I didn't mention any word. So it would have the value as world. And you can also step some of the values or skip some of the values. So if I say something like, let's say uh, print text of colon 2, that means it's going to start with 0, it's going to end with 13. Maybe I'll just mention this as well. So this is my starting index, this is my ending index. So basically I want to print all the words, but here I have a step. So what happens is it will try to print this entire string, but all the alternate characters will be ignored. So my E won't be there, my O won't be there, and so on. So let's try to print this. So we have HLOOL. So what happens is we print this H, skip the next step, print this L, skip this next L, print this O, and skip this command, so on. So this process goes on. So we have a step of 2. So you can have like any number of steps. So even you can skip 3. So every second character will be skipped, and we have this H, L, space, and R. So what happens here is like we print H, E and L will be skipped, and the third character will be printed, and then these three things will be skipped, and the next multiple of 3 will be printed. So if you consider this, right, so when you have 3, the third multiple, so we print this 0, the third multiple, this is printed, space is printed, R is printed, and so on. So you can similarly consider that for 2 as well. So when you have 2, 0 would be printed, the second multiple, L is printed, O is printed, space, 2 multiples, all those 2 multiples are printed. So this is how you can step through a particular value of string. Let's say that you want to access the last letter of the string. So there are two ways to do that. So you can either say print text of, let's say 12 is the last index, right? So you can do that, and it's going to print the last value. Or the other way would be to slice that and print it. So you can do that by saying -1 colon. So when you say -1, it's going to represent the last string value that you have, which is the exclamatory mark. So this is just accessing it using index, but this is like printing the last character but by slicing it. So we are slicing to only have the last letter of the string. So this is about it. And if you want to simply reverse the string, you can use something like this. So I can say text 0 colon 13, the entire length, and put another colon, and here say -1. So this is going to reverse your entire string. So I want to print all those words, right? So that's what 0 to 13 means, but I want to reverse that. So that's what this step of -1 means. So this reverse the string text, right? So we have the variable text, right? So when I print this, it's going to, sorry, one second, print text of 0 colon 13. So sorry, I have to say something like this, remove these two things. So don't mention that 0 to 13. So when we don't mention that, that means like I want to print all those things, but I want to reverse that string. So I can say -1. So these are some of the string slicing. So this is how you can access the individual characters by mentioning the index value, or you can slice this by using this colon and mention the starting index and the ending index. And we have to note that starting index value is included, but the ending index value is not included. And we have also seen how you can just mention the ending index value alone, or just the starting index value alone, slice specific parts of string, do stepping functions, and so on, and finally reverse a string. So these are some of the aspects. So now let's discuss about some of the string operations, or the methods that we can perform on the string, and let's call this as string methods. So one of the basic methods which we have already discussed is like length of strings. So here I can say length of allo. So here, instead of putting this in a variable, I'm just like directly finding the length of this string allo, and it's going to say 5. You can do this, or you can also print this, so that doesn't make any difference. So here we would have the value as 5. So when you are using any IDEs, this length of allo may not give you output, so you have to use the print statements. So maybe here as well you can use the print statement itself, which basically tells you the number of letters that you have. Again, this is not corresponding to the index, but this is depending on the count of the letters. So we have 1, 2, 3, 4, and 5. So we have 5 letters, so it says the value as 5. And then what you can do is you can do something like this: allo dot upper, open and close parenthesis. So this is going to give your value like this. So it's going to convert all the letters into uppercase letters. You can either do this way, or you can put this allo in a variable as well, and then say, let's say b is equal to, you know, a dot upper, and then print b. So this, what happens is, now a is still in lowercase letters, but what happens is we are taking this a, converting all the characters to uppercase letters, and storing it in b. So we are not altering the original a, right? So we are just like converting that and storing this in a variable called as b, and then we are like printing it. So this is how you can convert you know the string that has lowercase letters into uppercase letter. Or you can also do something similar to this, and then you can say, instead of saying b is equal to a dot upper, you can say a is equal to a dot upper and print this a. So this is going to say hello. And here there is a very critical point to note. Here we are not editing the original a value. Here we are creating a new value or a new variable, converting these letters into uppercase letter, and then we are storing it to the same variable. This is not same as editing this value, because strings are immutable. So here maybe I'll mention this immutable. That means you cannot edit a string value once it has been declared or once it has been created. So I cannot edit the original a value that has the value as hello in lowercase letters. But what I'm doing here is, here I'm not editing the original a value. I'm converting all this to a uppercase letters and creating a new variable with the same name as a and then storing this. So this is very important in the concept of mutability and immutability, where some data types are mutable like list, which again we will discuss later, but data types like integers, floats and strings are immutable. So here we are not editing it but just converting it to uppercase letter and storing it in a different variable. This is just similar to this, creating a new variable as b and converting uppercase letter and storing it in b. In this case we are just like using the same variable name, but don't assume that this is editing these values. So we cannot do that as strings are immutable. So this is another example. And then you can like consider like other functions as well. So here this is uppercase letters for converting it into uppercase letters, and then we can also convert like letters that are in let's say this is uppercase letters, and then we can use the method called as lower, and that's going to convert all the uppercase letters into lowercase letters, and then we can print this. And then we can maybe use something like print hello world, and I'm going to say dot string dot capitalize, and don't forget to mention your opening and closing parenthesis. So that's going to capitalize your first letter. So that means it's going to make your first letter in uppercase letter. So all the case just remains as it is. And the other is, you can use something like hello world, instead of capitalize say title. So we know that title, all the individual words are in uppercase letters. So this H and W alone are kind of converted into uppercase letters. And then you can also use something like this. So let's say that we have a string value that says hello, but that has like, let's say 3 spaces at the right side. So you can use this strip method or the strip function, put a parenthesis. When you print it, it's going to remove that spaces that you have. Maybe I'll just show you like this. So when I say hello and put this in quotes and just leave 3 space here, and let's call this a, and then let's just say a. So when I say print, you won't be able to see the spaces because we don't know where we have this closing brackets. But instead of print a, if you just say a, you will see that it's enclosed in single quotes or double quotes, right? So now when I use a strip, right, so when I say a dot a is equal to a dot strip, open and close parenthesis, and now print your a. Sorry, this is yes, so I have to mention a. So it's going to say hello. So now this trailing spaces are not there, so that's how we can use strip in order to remove the empty spaces that's present. Okay, so these are all some of the examples. And other few things that you have are, let's say that we have two strings. So the first string is hello, and the second string is world. So these are the two strings that we have. So if you want to concatenate these two strings or basically join these two strings, you can just simply say first plus second. So that's going to combine these two strings, and then you can just print this result. But when you concatenate these two strings, it's not going to add any space between them. So you would see hello world. If you want a space, either include it here or include it here. So you would say hello world, or even you can do this. So instead of saying this result is equal to first plus second, here you can insert another string, concatenate another string, which basically has opening and closing double quotes, and within that I am a string. So what happens is, first we have this hello, and to this hello we add a space as mentioned here, and then combine the second word, which is hello world. So this is going to add a space here. So this is how you can concatenate this string. And this is, maybe I'll mention the name of this. So this is string concatenation. So the next one is string multiplication. So let's say that I have a string called as Python, and I want to print this Python, let's say 3 times. So here I can say print uh, text asterisk symbol, which is for multiplication in Python, and say 3. So that's going to print the word Python 3 times. If you want a space between them, you can just add a space here after Python. So that's going to add a space between them. So if you want to print this in a new line, right? So you can put a new line character. So you can, instead of the space, put backspace in. So that's going to print this 3 times, as but we have new line. So each of these words will be printed in a new line. So this is how we can do string multiplication. And then we have discussed about this concept of string immutability, right? So let's understand that as well. Let's say that strings are immutable. So I'll explain this to you. Let's say that we have a variable called as text that has a string value of hello. Let's try to change the specific value. Let's say that I'm saying text of 0. So instead of h in the first letter of the string, so I'm accessing that with text of 0. I want to replace this with the value k. When I run this is throwing an error. It says string object does not support item assignment, or it's like another way of saying you cannot assign the value k to this particular index value. This is possible in the case of data types like string, where once you have, data types like list, where in list, let's say you have 5 values, you can replace the first value with a different value because lists are mutable. You can edit some values in the list, but in the case of strings, we cannot assign a new value to that string because strings are immutable. So let me just say this as this will raise an error as strings are immutable. So you cannot edit specific letter of a string once it has been created, or you cannot like change a particular, delete a letter or edit letter with some other letters. So that's not possible with string. So that's one thing. And then the other concept is like the string formatting, which we have already discussed before. I'll just like take a simple example, as we have seen this already. So let's say that we have name as John and age is 30. Let's say that we want to insert these values specifically. Instead of concatenation, you can do concatenation as well, as we have done here, but there is a concept of f string that's like widely used, and it's like much easier to do. So here I can say my name is curly braces, I'm going to say name, and I am age years old. Let's run this. So it says my name is John and I'm 30 years old. So what happens is, here we have variable and named it as name that has the value John, and the age that has the value of 30. So here I'm saying my name is name. So that means when I use a f string, I can put something in curly braces. So this part would be replaced with this variable value. So in this case, the variable is name, right? So this part will be replaced by this name variable value, that is John. And curly braces of age, this will be replaced with the age value of 30, and we are just like printing this. So this is how you can use f string in order to insert specific substrings into a different string. So these are all some of the different string operations that we do. Again, there are like lot more than this, but these are some of the basic stuff that should be good for you to get started with. You can also see like what are all the different methods that you have and different functions that you can perform on the string to just get a better understanding, but these should be good for now. So we have just started with basic string examples, and we have also seen how numbers can also be considered as string when you use double quotes. And the next topic is like multi-line string using double quotes and single quotes. And also we have discussed a lot about this indexing, how this indexing works, and also slice specific parts of string, and also use like step number as well, reverse a string, and so on. And then we have also seen how you can convert all the lowercase letters to uppercase letters, and lower uppercase letters to lowercase letters, capitalize, title way, strip that removes the space, and so on. And then we have discussed some of the operations like string concatenation, multiplication, and we have also discussed about immutability and f strings. So I hope everyone is clear with whatever we have discussed today. So please practice these codes and try to get hang of it. So you may forget like few things at start, but like once you start practicing it, like did this a few times, you would get like a better understanding and remembrance for this. So that is all I wanted to discuss today. So I'll see you in the next upload. Thanks for watching. Hello everyone, I'm Siddharthan. This is the 13th video in our complete Python course, where we will be discussing about operators in Python. So we have different operators like arithmetic operators, assignment operators, comparison operators, bitwise operators, and so on. So in this video, let's understand in detail about all of these operators individually. So this will be the agenda, and let's get started. So I'll be doing this coding in the Jupyter notebook, but you can feel free to use any other IDEs or notebook of your choice. So the first thing that we'll be discussing is arithmetic operators. So I'll just create a text cell by clicking here and changing this to a markdown so that I can write some text here. And the text for this would be arithmetic operators. So arithmetic operators is basically used to perform arithmetic operations such as addition, subtraction, multiplication, and so on the integer or float values that we have. So maybe I'll create another text and say like what this is about. So these are used to perform mathematical operations like addition, subtraction, etc. So this is like the purpose of this. So we can use this to perform mathematical arithmetic operations. Let's start with addition, and maybe before that I'll just assign two values to the variables. Let's say that we have x value as 10 and y value as 5. So these are the two things that we have. And now you can say print addition. So the addition value of these two things are x plus y. So what this would do is add the two numbers x and y, that is 10 and 5. So we would get the value as 15, and this would print this after this string called as addition. So we have this addition string, put a comma, so that's going to add a space after this and give the addition value. So x plus y value, that is 15. So similarly we can do this for subtraction, multiplication, and so on. So maybe here I'll write a comment saying that this is for addition operator. So this is nothing but the plus sign. Okay, maybe I'll put this here. So put a tab space. Okay. So let's say that plus. So plus symbol is what we basically use for addition operation, right? So that's the addition operator. And then we have subtraction operator. This is for subtraction. And here we know that we use minus sign. So here I can say x minus y. Even we may get negative values as well, right? So this would be subtraction. So x minus y. So we would get the subtraction. You can also simply say that instead of putting this in a variable, you can say something like 5 minus 10. So that would give you the result. So you can put these operations within a print statement as well. So this is for a simple subtraction that can be used using a minus sign, or you can also put a space between these things as well. So that's valid as well. So you can say x space minus space y, and that would give like the same result. And let's say that we have multiplication operation, which is represented by the asterisk symbol. So here I can say print x space asterisk comma y, and maybe here I'll put the string value as multiplication. Okay, so this would multiply this 10 and 5, which is my x and y, and it would give the value as this 10 into 5, which is 50. So we would get the multiplication value. And then we have division. So here I can say print division colon comma x forward slash y. So for division we use the forward slash symbol. So we would get the division result. Basically watch the quotient. So when you divide 10 by 5, the quotient is 2. So we have the value as 2.0. So the quotient is what we get using this division. And then you can use modulus as well. So modulus print, we have this modulus, and you can say for modulus we represented by percentage. So x percentage y. This also does the division, but it would give you the remainder value. So when you divide 10 by 5, the remainder would be 0, right? So you would get the value as 0. But what if you multiply this, what if you divide, let's say 10 as 3? Sorry, so we have 10 here and 3 here. So basically we are dividing 10 by 3, but we are not interested in the quotient as using this forward slash, but I want the remainder. So when I say this 10 percentage of 3, it would give the modulus or the remainder as 1, because when you divide this, that's what you get, right? So you have 10 by 3, you put 3 as the quotient, you would have 9, but the remainder is 1. So that's the result we would get. So that's how you can use this modulus operator, and all this can be inside a variable as well. Let's say that we have x is equal to 10 and y is equal to 3, and the result is z. So z is equal to x percentage of y, which is 10 divided by 3, but we want the remainder, so we are using that and say z. So you would get the remainder as 1. So this is for modulus operation. And finally we have exponential operation. So let's call this exponent, and for this you use double asterisk sign. So you say print let's say exponent. So this would be, let's say we create the x values as x, the same values, x is equal to 10 and y is equal to 5. So this is just like saying 10 double, so sorry, 10 should be here, double asterisk 5. So you can add spaces or remove the spaces, that's not going to matter. So we would get the exponent 10 to the power 5, and we would get this as our value, which is like, let's say 100,000, right? So this is how you can perform exponent operation by using double asterisk sign. So these are all the arithmetic operators that we have. So we have addition, subtraction, multiplication, division, modulus, that's going to give us the remainder, and then finally we have exponential operation. So these are the examples of arithmetic operators. So the next type of operators that we are going to discuss is assignment operators. So let's put this in bold. Okay, so now we have this assignment operators, and I'm going to say x is equal to 10. So this is what we call as assignment. So we are assigning the value 10 to this variable x, right? So we are using this equal to symbol, which is nothing but the assignment operator that we are using. So when I say x is equal to 10, as I said, to this variable x, we are assigning the value 10, and then you can print the value of x here, and you can also check the type of x and so on. So we know that we can use this, and we have discussed about this in variables as well, right? So this is a simple assignment operation where you're simply assigning a variable or a value to a variable. There are different variations that you can perform here. So you can say x plus equal to 5, right? And let's print this x. Let's say what we are getting here, or maybe let's say that first we are assigning x value as 10, just like the previous case, and then saying x plus equal to 5, and we would get the result as 15. So what this plus and equal to assignment operator, so this is another assignment operation. Let's try to understand this. So this is same as, so this plus equal to in this case is same as saying x is equal to x plus 5. So instead of saying x is equal to x plus 5, I can say x plus equal to 5. So to some value, so already x has the value 10. To that I'm adding a value of 5. So that's what we mean by this, right? And storing this entire value in the same variable. So basically I have this x is equal to 10, and I'm adding this 5 to this 10, and I'm storing this in the variable called as 6. That's what is basically happening here. So this can be written simply as x plus equal to 5. So this can be done for other operations as well. Like let's say x is equal to uh, let's say uh, 10, and x minus equal to, so minus shouldn't come after equal to sign, so minus should come here, equal to, let's say 3. So this is same as saying x is equal to x minus 3. So the result should be 7, right? So let's print this x. So the result is 7. So this can be again done for other operations as well. So let's say that we have vx equal to 10, and then x asterisk, which is multiplication, is equal to 2. So this should give the value as 2, because this is just like saying x is equal to x into 2. And I can just say print, maybe I'll put this as after asterisk and equal to, we get the value as x. So the value is 20. So after this, we are basically multiplying x with this 2 with 10. So x is equal to, so this can be written as x is equal to x into 2, which is nothing but 10 into 2. So we get the value as 20. The next example is just using division. So I can say forward slash equal to 2, which is x divided by 2, and that would give the value as 5.0. Okay, so the division thing. And then finally we have exponent. Even modulus can be done here. Maybe you can try modulus and other operators if I miss something. So here you can just say double asterisk, which is saying x to the power 2, which is 10 power 2. So after this, let me put a forward slash here, and the value would be 10 power 2, which is 100. So these are all the different assignment operators that we have, where we have first discussed how we can just assign a single value to a variable. And then we have also seen how you can use this plus equal to sign, minus equal to sign, and so on. So these are all the different assignment operators that we have. And you can also assign multiple values to multiple variables as well. Let's say that we have x, y, and z, and then I have the values like 10, 20, and let's say 50. So when I print this x, y, and z, so here we are just assigning like three values to this. So x takes the value of 10, y takes the value of 20, and z takes the value of 50. You can also say x is equal to y is equal to z, which is equal to 50, and print x value. I'll copy this three lines that I have over here and say this. So here for x, y, and z, for all these three values, I'm assigning the same value, that is 50. So this is how we can use this assignment operators in different ways. So this is the second operators. The next operator that we are going to discuss is a comparison operators. So here I'll make this bold and say 3 is comparison operators, which is basically used to compare some values. Let's say that we have a value as 10 and b value as 20. So these are the two variable values that we have, and I'm going to compare this, just checking if a is equal to b or a is less than b, greater than b. So those comparisons, those simple comparisons. So here I'm going to say just some string values, or maybe I'll just show you a simple one. I can say print a is greater than b. So here basically I'm checking if a is going to be greater than b. We know that a is not greater than b, so it's going to return a false. So all these comparison operators would return true or false, or basically your boolean values. So here we get a boolean value. So the next thing that we can check if a is less than b, and we know that it's going to return true, right? And maybe you can check if a and b are exactly the same. So you can say a is equal to b. So you shouldn't you say a is equal to b, so that's like assignment operator. But if you want to check if both the values are equal, you have to use double equal to. This is very important because this we use like in a lot of places to kind of like check whether a particular, you know basically two variables are as the same value, not same, but two variables as the same value. So we check that over here. So this is that example. So a is equal to b, and of course both the values are different, so we get this as values. But what if, let's say, c is equal to 100 and d is equal to 100 as well, and then I can print this a is equal to, sorry, c is equal to d. So this would return true because both c variable and d variable, so these are different variables, but these two variables has the same value, right? So there is a difference in like what I'm saying. It's not like the same variables, there are like two different variables, but these two variables has the same value. So here we are returning a true. And now let's again come back to this example. Maybe I'll declare this again so that you can easily see this here. We have a is equal to 10 and b is equal to 20. So you can check whether a is not equal to b. So not equal to can be used with this exclamatory mark and equal to. So when you say equal to, it checks whether both the values as both the variables are same value. But when you say exclamatory equal to, it checks whether both of these values are different. So you can print a is not equal to b. So when the two values are different, it should say true. But if you perform this over here, it should say false because it checks whether the two values are different. But in this case, the two values are same, c and d are same. So that's going to return a false to you. Okay. So that's how you can use this equal to or like not equal to comparison operators. And then we have this greater than or equal to, less than or equal to as well. So here I'll check whether a is greater than or equal to b. So this means this would return a true if a is either greater than b or if a is equal to b. So when I run this, it's going to say false because a is less than b, right? So we know that. So a is 10, b is 20. So instead we can use a is less than or equal to b. So this satisfies two conditions. One is it checks if a is either less than b, or if it is like equal to b. So in these two cases it would return a true. In this case it would return a true. So these are like simple comparison operators that we know, and this is like not complex stuff at all. So I hope that everyone get this. It's just like taking two values and just comparing if they are the same or if they are different, or one value is smaller than the other, or the other value is greater than the other, or one value is smaller than or equal to the other, or it's like greater than or equal to the other. So these are all the different comparison operators that we have. And in the next step we have logical operators. So I'll create another markdown cell here, and this is the fourth operator that we are going to discuss, and that is nothing but logical operators. So these are used to combine two conditional statements. So in the previous case, again, these are like we are trying to compare two things, right? But what if you want to compare two conditions? Let's say here we have this a and b. So this we have did here. But what if like you can do this separately? A is less than or equal to, like basically multiple condition, not only two, but multiple condition can be checked. So for that we can use logical operators. So here this would be logical and operator. This is like similar to the logical gate that you probably would have studied in your 12th grade on, or basically if you're studying engineering, you might have studied this in your first year, right? So we have AND gate, OR gate, NAND, NOT gate, and so on. So it's kind of similar to that. So these logics thing. Let's say that A is equal to 10 and B is equal to 20. So we start with these variable values and print A is greater than 5 and B is greater than 15. So here we are checking two conditions. We are checking if A is greater than 5 and B is greater than 15. So first let's say what's the result of this. So we know that this is operators, comparison operator, that are going to return either true or false, right? So when I check A is greater than 5, I check whether if 10 is greater than 5. Of course 10 is greater than 5, so this part would return me a true. And here we are checking if B is greater than 15. So we know that B is 20, which is greater than 15. So here we have something like this: print true and true. So when you have two trues and when you use and, both these conditions should be satisfied. Both these conditions should return true. Then only this would return true. If not, this would return a false. So we would get the output as true because both these conditions are kind of satisfied. So maybe let's try something like this. So when you put true and true, when both these are true, we would get the result as true. But when one is true and one is false, it's going to return false. When both are false, it's going to return false. So both these conditions should be true for it to return true, right? So this is what we have done. So when it compares, it would have this condition where print true and true, because this would return true, right? So we compare these two things and get the result as true because the two conditions has been satisfied. So now let's compare it for logical OR operator. So logical OR is different in a way where, maybe I'll first show this to you. I'm just going to take these conditions only and replace this AND with OR. So in the case of OR, again, this is a keyword. As you can see, this is like green in color. So it's like keyword in Python, just like lowercase and for OR, it's like lowercase or OR. So either one of these two things should be OR. The order doesn't matter. So either like both values can be true, then it's this OR operator is going to return true. Or if one of these two things is true, it's going to return true. Let's run this. So in the first case, we have both the things are true, so OR is going to return true, just like the AND thing. And in this case, only one value is true, so it's going to return true. But AND would return a false because it requires like both conditions to be satisfied. And finally, when both are false, it would return false, right? So now let's consider like a similar example here. A is equal to 10 and B is equal to 20, right? So let's consider the same example. And instead of AND, we are going to test OR operator, and we are going to test the condition. Let's say A is greater than 15 and B is, let's say, less than 15. So in this case, A is greater than 15. So this is a false, right? Because A is just 10, it's just like less than 15, and B is less than 15. So here B is less than 15, of course B is not less than 15. So in these two cases we are getting both as false. So we would get the, okay, so this should be OR. So both these are false, so we get this as false. Let's maybe try another case where let's say A is greater than 15 or B is greater than 15. So what I want is one of the two numbers should be greater than 15. In this case, the first condition A is greater than 15, so this is going to return a false because 10 is not greater than 15. But B is greater than 15 because B value is 20. So now the first print statement is going to return me a true. The next print statement is going to return a, sorry, this would return a false, and this would return a true, because in this case both the condition, the first case both condition has been not satisfied, whereas in the second case the second condition has been satisfied, so we would get the result as false and true. So this is a or operator is used, and then we have this not operator which basically just like inverts true to false and false to true. So when I say print not of A is greater than 15, basically A is not greater than 15 because A value is 10, right? So it's less than 15. So you would get a false here, but this false would be inverted using this not. So you would get a true here. Okay. So when you put a true within this not, you would get false. And when you put a false within this not, so that would, give you as true. Okay. So this is all about it. So when you put not A is greater than 15, so it would have something like not of false, and that's going to basically give you a true as the output. So these are all some of the basic logical operators that we have. So first we have discussed about arithmetic operators, then we have discussed about assignment operators of how you can assign values to the variables, and then we have discussed about this uh, comparison operators to compare like two values or variables basically, and then we have discussed about logical operators. The next operators, which is like slightly different from these things, is a bitwise operator. So I'll put this as 5 bitwise operator. So pay close attention to this. Let's say that we have x value as 5 and y value is 3. Each number as a binary representation, and the purpose of this bitwise operator is to perform operation on the binary representation of the values. So this is what a bitwise operators does. So binary is nothing but like 0 and 1. So basically two numbers. So and all these values can be represented as binary numbers. So we have, let's say, 4-bit number, 3-bit number, and so on, right? So let's try to understand what would be the binary representation for the number 5. So this again, if you don't want to go into the basics of how to convert these numbers and so on, just simple stuff. But if you just quickly want to understand what's the binary representation of 5, you can just search 5 binary value. So five binary value is 101, but let's say we want it in 4-bit. So we would have basically 4 bits. So we have like 4 numbers, right? So each one is a bit. And this is like a 3-bit representation. So in 3-bit representation, the value 4 can be represented as 100. In 4-bit, it can be represented as 0100. 5 can be represented as in 3-bit 101 and 4-bit 0101. Let's say that we are focusing on 4-bit binary numbers. So the binary representation for 5 would be 0101, right? And in the case of 3, this would be, let's check it. 3 can be represented as 0011. So I can put this as 0011. So now what this bitwise operator is going to do, it's not, if you try to compare or do something, it's not going to compare these values, but it's going to do these operations on the binary representation of these numbers. So the 5 is represented as 4-bit numbers here in Python, and let's say 3 as a binary representation of 0011. So it's going to do the bitwise operator operations. Okay, so let's understand this. So we have x value as 5 and y value as 3, and we have also mentioned the corresponding binary representation. So first let's discuss bitwise AND. So bitwise AND is done by using the symbol, this AND symbol, ampersand symbol. So we have this AND symbol, right? So that's going to do that. So when you say print x and y, so it's going to return the value as 1. Now you may not know what this basically means. I'll explain this now. So when you have 5 and 3 and when you have this and, right, so what this will do is, let me make this as a text cell. Let's say that 5 is represented as 0 0, sorry, 0 1 0 1, right, and 3 is represented as 0 0 1 1. So now if it is a AND, if you want a 1, both the values should be 1. So let's put these two things side by side. So first, like, let's say let's put the first value of 5 and the first value of 3, and then second value of 5 and the second value of 3. So this would look something like this: 0 0 1 space 0, and then 0 space 1, and then we have 1 space 1. Let's try to understand this. So what I did here is, this first column value, right, 0 1, so this 0, this one, this 0, this one, so this basically represents your 5, and this 0 0 1 1 represents this 3. So I've just like written this in a column wise way. Now we have a and, bitwise and, right, so it basically do a comparison of these two things. When you put a and between these two things individually, so we, let's say we put a and here, again we put a and here, it's like doing this. So for each bit we do this AND operations and try to see what's the result. Okay, so it compares all these bits individually. So when both the values are 0, you would get the value as 0. When one value is 1 and the other bit is 0, again you would get the value as 1 in the case of AND, because for AND to give 1, both the values should be 1. This would have the value as 0 because one of the bits is 0. And finally we have in this case both the values as 1. So now you would get the value like this. So in the case of comparison of the first bit in both the values, 0 and 0, so when you put 0 and 0, you get 0 as the value, and you have 1 and 1, 1 is the value, 0 and 1, you have 0, and in this case only we have like both the values as 1, and you get the value. Now what is this binary number? 0 1 0 1. So the binary output is 0 1 0 1. And if you open your Google and search for 0 1 0 1, let me type it here, 0 1 0 1, binary to decimal. So that value 0 1 0 1 is 5. Oh, okay, not this. Oh, I think I made a mistake. So, oh, okay, so this should be 0, right, because one of these is 0, so only the last value should be 1. So sorry for that mistake. So the value should be 0 0 0 1. So if I check for 0 0 0 1 binary to decimal, that number basically represents the decimal value 1, or basically the floating point on, or the numerical value of 1. So that's what, when you do this x and y, bitwise and y returns. So it returns, it basically do this AND operation individually for all these bits for these two numbers, get the final binary output, and represents like what that particular value gives you. So now when you do this with OR, right, let's run this. Maybe I'll put this in the next line so that you can see separately on the text cell. So this is what we have seen. So this is the binary output for this. Maybe I'll write it here for you to understand. So binary output of 101. This is the explanation for that. Let me put this as bitwise and explanation. Let's do this for OR as well. So we have like, let's say again two numbers, 5 and 3. And now instead of bitwise AND, I'm going to do bitwise OR. So bitwise OR can be used using this vertical bar symbol. I don't know what's the exact name for this. It's like in the key of backward slash just above enter symbol. So you would have this vertical bar symbol, right? So this straight bar thing. So this is for binary OR. Now let's see what we are getting over here. So it's basically the same thing. So instead of AND, we are going to do OR. So one of the bits should be 1 for it to give 1. So this is bitwise OR. In parentheses, I'll put this vertical bar. So we have 0 1 0 1 as the binary representation of 5 and 3. And instead of AND, we would have this OR symbol. Okay. And in the case of OR, just like the logic gates, for it to give 1 as the value, one of the values should be 1. So in the case both the values are 0, so OR would still give 0. And in this case, the first value is 1, so it would give the value as 1. In this case, 0 and 1. One value is 1, and in this case, both the values are 1, so it would give 1. So this is how the OR would give the value. And now look for what's the binary, the decimal conversion of 0 1 1 1. So 0 and triple 1. So here I can say 0 triple one, and the binary to decimal value for that one 0 triple 1, right, is 7. So when you run this x bitwise operator of OR and y, so that's going to give the value as 7. So this is how the bitwise operator works, where again we are doing the same logical OR comparison, but not just on the numbers but on the individual bits that we have in those numbers. So this is how bitwise OR works. Finally, let's just like look at bitwise NOT, which just like converts one bit value into another. Let's say that x value is uh, you know 5 and yeah, and now let's print x of, so for not, you can bitwise not, you can use this symbol, absolute symbol, and then just like use x. So it would give -6 because that's the binary output that you get. You can maybe check -1 binary representation. Sorry, what's the value? So it's -6, right? So when you do a not bitwise not for 5, you would get, let me put this as -6, binary numbers representation. Let me check this, because negative numbers probably like as larger bits. So let me do this as number to binary converter. So here in this converter, let's say that decimal to binary. So I want to convert 5 to, let me put this as 0. Okay, convert. So we have this 101. So we have 2's complement. Okay, let me put this as 4-bit maybe, so that it's easy for us to understand. But when you put this -6, right, so that's going to have this as my bit value. Okay, so we have like several ones here, 0 1 0. So this is how your -5 would look like when you do this not operation on the bits. So we would get the value as -6. Okay, so this is like the binary representation of this. I'll see if I can show this to you in an easy way. Not of -5, sorry, +5 in binary. So this is what we have. So we have the bitwise not of 5 in binary is -6, and we would get the value like this. So not is represented in this, but again this is probably like a larger bit number, but the result that we would get is this. So all these values that we have, 0 0 0 0, which is like a larger bit, not 4-bit but larger bit is this, and we would get the value as -6. So this is how the not operator works here. Okay, so this is the other example. And the final sorry, we have like two more operators. One is like the membership and the identity operators, which is like pretty simple stuff. So here I'll say this is the sixth one, right? Fifth one, this is the sixth one. So all this can be explained not only with 4-bit, but again if you increase the number of bits, here let's say we consider like a larger bit for 5 and similar number for 3, you would still get the same value, and this is like similar to that as well. So it's like not different in comparing it, like let's say when you compare two numbers in 4 bits, it's going to give the same value when you compare it with like larger bits, but both these should have the same number of bits. So that's about it. So in this case the value will be -6. So that's about it. And moving on to the next operator, so that's about membership operators. So let me put this in bold. So membership operator basically used to test if a specific value is in a sequence. Sequence is nothing but, if it can be a list or a tuple, basically sequence are sequence data types like that has like multiple values. So a list can have multiple values, but integers are like one value, right? So these are membership operators. Let's say that we have list as my list is equal to, let's say, 1, 2, 3, 4, and 5. So there are like 5 values. So check if let's say 3 in my list. So this in is my membership operator. So that's going to check if the value 3, if it's present in my list. So it's going to check that. And this is also return you either true or false, the boolean values. So when I run this, I get the value as true, right? And then I can check something like print 10 in my list. So 10 is not in my list, so it's going to give the value as false. And the other version that I can check is not in. I'm checking if 3 is not in my list. So this would just like alternate the result that you just basically got here. So this checks if, so for it to return true for this not in, 3 should not be present in my list, but 3 is present. So this is going to return a false, just like alternate of the result that we are seeing here. So this check if 10 is not in my list. Of course, 10 is not in my list because it has values only till 5. So this is going to return a true. Okay, so when I run this, I get the value as false and true. So this is how membership operators works. So the last operator that we will be discussing is an identity operator. So I hope you are clear with membership operator that we have discussed now, which is like all about checking if a particular value is present within a list or let's say a tuple or something. So the next one is about this. Let me make this as a markup and mention this as seventh operator, which is identity operator. So let's say that we have three lists. So again, we would discuss about this list later, but list basically has like multiple values in it. It need not be like all should be an integer or float. So we can have like mix of integer values, float values, and so on. So let's say that we have variable x that is nothing but a list that has the values 1, 2, and 3 that's enclosed in square brackets. So when you put something in square brackets, so that becomes a list. And let's say y is equal to, it's also the same thing, 1, 2, and 3. But we have another variable called as z that represents x. So now we are creating a variable and assigning a value to this, which is a list 1, 2, 3, and creating another variable to this. So both x and y have the same value, right? But they are not the same. So this is like, let's say, consider having two identical red colored balls. They are the same, but there are individual balls. So similarly, we have two individual lists which are the same list that has the same value 1, 2, 3, and 1, 2, 3. So the first list is in the variable x and the second list, which is the same list, is present in the variable y. But here we have said z is equal to x. So here we are not creating a new copy of x, right? So z is not a new copy of x. It's not a new copy of this list. In this case, z, when you say z is equal to x, it is just that z is a reference to this variable x. That means in memory, we are not creating a new list as 1, 2, 3. Okay, so let me explain you this again so that you get this properly. So here we have 1, 2, 3 as the list. X is also 1, 2, 3. So we have two identical lists present in two different variables. But when you say z is equal to x, here we are creating a new reference, but we are not creating a new list. So here z is actually x in memory. So we don't have like separate list in the case of memory. So when I say print x is y and say print, let's say uh, z is, or let's say x is z, and print x is not y, these are the outputs that we are going to get: false, true, and true. So here identity operator basically checks if two variables are the same thing. In this case, z and x are the same thing, or basically the same value, because for Z, we are not creating a separate object in the memory. But in the case of Y, X and Y are separate objects in memory. So X is one list that has values 1, 2, and 3. Y is another object that is like 1, 2, and 3. So there are like separate objects in memory. But in the case of Z, it just refers to the same value in the memory. X and Z refers to the same value. So when you say X is Y, it's going to say false because these doesn't represent like this, right? So these are like individual objects. So this is going to return false. But when you, okay, so this should be X. So, but when you check Z is X, it's going to return true because X and Z are same thing. So this identity operator basically checks this. If two variables just like points to the same value, or basically they are the same thing, they're just like reference of the other. But when you check X is Y, you're getting a false because X and Y are not the same thing. They are like identical list, but they are like present separately. And when you put a not, it's again just like using a logical not, which is going to turn true into false, right? So when you say X is not Y, it checks whether X is not same as Y, which is right, because it's not referring to the same value or the same variable basically. So you would get the result as true. So all identity operator does is it checks if two variables represents the same thing in memory. So Z and X represents the same thing in memory. So here we are getting a true, and here we are getting a false, and here it's just like checking not condition is not condition. So we know that this is not X is not Y. So we get the value as true. So this is about identity operator. So you may feel like a bit confusing a bit, but I mean once you like try this, it would like make better sense to you. Like consider more example and like try few other examples of this identity operator, you would definitely get this. It's all about making sure that two variables are the same object in memory. So that's about it. So let's just do a recap of what we have done. So first we have discussed about the different arithmetic operators like addition, subtraction, multiplication, and so on. And the next is about assignment operators. So how you can assign values to the variables, print it, use plus equal to, minus equal to, and so on. And the next operator is comparison operator, which is basically used to compare two variables. And then you have logical operators of using the logical and, or, and so on. And then we have bitwise operator, which is an interesting operator to kind of compare values bitwise. And then we have membership operator to check if there is a list or a tuple, if one value is present in that sequence. So for that, membership operator is used using this in. And then we have identity operator, check whether two values represent the same thing in memory, and so on. So I hope everyone discussed whatever we have discussed today. So please try this, and you will definitely get a better understanding of this. So that is all I wanted to discuss today, and I'll see you in the next upload. Thanks for watching. Hello everyone, I am Siddharthan. This is the 14th topic in our complete Python course, where we will be discussing about list, tuple, set, and dictionary. In the previous sections, we have discussed about the data types such as integers, floating points, strings, boolean, etc. And these are single data points. So you can have like single integer, single floating point, single string, and so on. But list, tuple, set, and dictionary has the capacity to hold multiple data points. A list can have, let's say, 10 integers, or a mix of 5 integers and 5 floating points, and so on. So they can like hold multiple data points just like arrays. So this is what we will be discussing in today's video, and let's get started. So I will be doing this coding in my Jupyter notebook. You can use Google Colab or other IDEs as well as usual. So first I'll just like create a text cell here by choosing Markdown, and first I'll mention this as list. So first let's discuss about list data type. So list is just similar to an array that we have in C programming. The main aspect about list is like it's not like you can only store integer values. You can also like store a combination of integers, floating points, and any data types that you have in Python. So let's say that we are creating a list first. So this is for creating a list. And here I say my underscore list. So this is the variable name that we are creating, but you can have any names, list underscore one, list underscore two, or anything. So here I'm creating this as my underscore list, which is equal to, so we have to put the values in square bracket. So when you use square bracket, that means it is a list. And also you can have empty list as well. So this is basically an empty list. So if I print this, right, my list, so this is going to just print this empty square bracket. But if you check this type of my list, it's going to say it is a list. Okay, or even you can just put a print statement before it would say that it belongs to the class list. So this is how you can initiate a list with a empty list. Now let's see how we can add some values to it. So the list values or the list elements are separated by comma. So I can say 1 comma 2 comma 3 4 and 5. So this list has, let's say, 5 values. So when I print this, the list will be printed like this. And if you want to look at the total number of elements that's present in a list, you can just simply say print length. So the same function that we would have used in the case of string, which would tell you the total number of characters, spaces, and everything that you have in a string, right? Whereas in this case, the print length would give you, let's say, my list. So we are putting this my list within the parenthesis of this length function, and that would return the total numbers as 5. Okay. And as I said, you can have any data types there. So I can have, like, in this case we have only considered integer values, right? But we can also say 1 comma 2 comma 3.5 4.67, and let's say true, which is boolean, right? So with uppercase T. And then I can also say Python, right? So these are like this is an example where uh, you can have multiple data types. It's not like limited to a list can have only integer, or it can have only floating point value. So it's not like that. It can have like these mix of data points. So that's about it. And then again I can print this my list, and this would print the list with like all those different data types here. So if you want, you can again check this type that would say it as my list. Maybe I'll just copy this. So here we are creating this list with the same variable name my list, but you can just like feel free to use a different name as well, so that shouldn't be a problem. So that's another example. And list are mutable data type. So maybe I'll put a markdown here and I'll write this here. So lists are mutable. That means you can change the values once you have created the list. But in the case of integers, floats, strings, and so on, you cannot change the values once it has been created. In the next video, I'll explain you in detail about this mutability and immutability. But just remember that lists are mutable. Mutable means we can change the values once the list has been created. We'll put it this way. So lists are mutable. That means values can be changed in the original list once it is created. Okay, so that's about this immutability. I'll put this part in bold using this asterisk marker. So let's say that we have a my list, right? So let's say we are considering the same example of my list, right? And then I can access individual elements of this list by saying my list of, let's say, 0, right? So when I print this, that's going to say 1, right? So this is how you can access the individual values. And as we said, lists are mutable, right? So one example for that is, let's say that we have created a list and that's stored in this my list variable. If you want to add a new value, you can simply say my list dot append, and it's just some value, let's say 50. So this is going to append this value 50 to this existing list. Wait, let's move this up. Let's discuss this index later. I'll just like append this value. So this is going to take this my list and add this value 50 to this original list that's stored in this variable. So this is why we say that lists are mutable. So I'll run this, and once we have appended it, we are going to print this my list. When you print this, you get the value as 1, 2, 3.5, 4.67, true, Python, and 50. So this is how you can edit the list once it has been created and it's still in the same value. So we are editing the original list that has been created. So again, we can edit specific values that's present in a list. So that's why we need to understand this concept of indexing. So we have also discussed about indexing in the case of strings, and we have discussed that in Python indexing starts from 0. That means you start counting from 0. So you call this number as index 0. So that means, like, index 0 is the first number, index 1 is the second number, and so on. So this 1 would have the index of 0, 2 would have the index of 1, this number would have the index of 2, and so on. So this would like look something like this. The indexing would be 0, 1, 2, 3, 4, 5, and so on, right? So index of 0, so my list index of 0 represents this value 1. Index of 1, which is this value, represents this one. So when you say my list of 0, it means print the value that's present in the index 0. So that's going to be this number. Okay, so I'll run this. So similarly, you can just like print other values as well. So when I put 2 over here, so the index 2 is, this is 0, this is 1, and this is 2. So it's going to print 3.5 here, let's say. So it's printing 3.5. So this is how you can access specific values using their index number. So using this index value, as we said, list are mutable, we can change the values as well. So I can say my list of 2 is equal to, let's say, 100. So what I'm doing is accessing this my list of 2, which is this 3.5, and I'm trying to change this value to 100. And I can print this by saying my list, right? So when I run this 3.5 that was originally there, so this has been replaced with this 100. So this is how you can edit the list values using this indexing. So you can just mention the index and just like replace the value. So as this is mutable, we can also remove certain values. So this is for removing an item from the list. So here I can say my underscore list dot remove, and in the parenthesis mention the value you want to remove. Let's say that I want to remove this value 4.67. So I will just say my list dot remove, mention the exact value that you want to remove, and then you can finally print my list. So this is going to say 1 to 100. So this 4.67 is not there anymore. So this is how you can delete a particular value that's present within a list. So that's the other thing. Okay, so this is why we say that lists are mutable. So these are like very basic stuff about list, and once we discuss about mutability and immutability in the next video, I'll explain you in detail about this list and also like other detailed operations that we can do. So there is like more to it, like how to create list with for loop, and how for loop and list kind of plays together and so on. There is like more to discuss. We will be discussing that, like, and how to append to list and so on. So that will be discussed in that video. But this is in this video I just wanted to give you a quick introduction to this particular data type of list, and then we can move on to this tuple set dictionary and so on. So here we have successfully discussed about list. Now I'll create another markdown cell here and I'll name this as tuple. So tuple is another interesting data type. It's just similar to list. The only difference, or the main difference, is that tuples are immutable. That means you cannot change the values once you have created them. You can kind of store it in a different variable, but you cannot like change that original value as we have did with list. So here I'll say I'll change this to markdown by just clicking here and pressing M button, and here I can say tuples are immutable. That means you cannot change the values that's present in a list. So values of a tuple cannot be changed, just like you know a list, right? So tuples are immutable. Now let's say that we are creating a tuple, and I'll call this as my tuple. So I can say my underscore tuple is equal to. So we know that lists are enclosed in square brackets, right? Whereas tuples are enclosed in parentheses. So I can say 1, 2, 3, 4, and 5. So these are the values that I have in tuple, and then I can just print this as my tuple, and it will just like look similar. Your tuple is enclosed in this parenthesis, right? So this is how you can create tuples. There are also conversions possible. Maybe I'll just give you an introduction to that, but let's discuss that later when we discuss in detail about tuples or list maybe. So you can kind of convert a list into a tuple as well. Let's say that we have a list like this: 1, 2, 3, 4, and 5. So this can be converted into a tuple by saying my tuple is equal to, use the keyword Python keyword tuple. So tuple is like a keyword that we have in Python. As you can see, this is turned green in color. Now you can pass the list that you have created and print my tuple and print the type of my tuple. So here we are creating a list and then later converting it to a tuple. So either you can create this directly by using this parenthesis, or the other way is you can create a list and then convert it using this Python keyword of tuple. So I'll run this. So it's going to convert this list that's present in square bracket. So look at this parenthesis or the square brackets type. If it's in square bracket, it is a list. As you can see, this my list that's present in a square bracket has been converted into a tuple. As we can see the parenthesis here, and we have also printed the data type over here. So this is how you can convert a tuple into list. So similarly, you can also convert tuple to list as well. So let's say that we have this as the tuple, and this can be converted into, let's say I'll call this as list1. List underscore 1 is equal to, use the keyword list. So list is the keyword to mention, list data types, and pass my tuple here. And then you can just print your list and also the type of this list. So first we have started with a tuple, and now we have converted into a list. So this is how you can do this conversion of one data type to another. So from list to tuple and tuple to list, right? So this is another thing about it. Maybe I'll copy this again. Now let's work with tuple. So we have my tuple value as 1, 2, 3, 4, and 5. And similarly, you can have like multiple data types as well. It's not like it can only have floating point values or integers alone or something. So it can have mix of these data types. I'll say maybe Python. So it has like mix of integer, floating points, and string now, right? We can print this as my tuple. So we have these values, and similarly you can just like check this type by just running this print type my tuple. Okay. So now similar to list, you can access the values that's present in a tuple using index. So I can say print my tuple square bracket 0. So whenever you want to access values using index, you have to put that index value with its square bracket after the data type. So here the data type is stored in the variable called as my tuple. So after my tuple, I can mention the square bracket, mention the index value. So that's going to print that number. So my tuple of 0 is nothing but 0th value, which is 1. So this is 1 belongs to index 0. This 2.5 belongs to index 1. This belongs to index 2 and so on, right? So my tuple 1, and we get this value, right? So we are just accessing it within index, but as tuples are immutable, we cannot change the values as we have did here. So here we have accessed a specific element in the list, and we have changed it. So in the case we have changed this 3.5 to 100, right? But we cannot do this in the case of tuple. Let's say that I'm saying my tuple of let's say 2 is equal to 100. So that's going to throw a error saying tuple object does not support item assignment. So tuples are immutable. That means you cannot change, edit, or delete any values once it has been kind of created. So even you cannot like append any values as you would do in a list. So that's like the main difference between tuple and list. So that's enough about tuple. So the next data type that we will be discussing is a set. So I'll say this as set. So let's create a set. So sets are enclosed in curly braces. So lists are enclosed in square brackets, tuples are enclosed in parentheses, and set is enclosed in curly bracket or the curly braces, like you whatever you call them. So let's say that I say my set is equal to the curly brackets, and I can say 1, 2, 3, 4, and 5, and then I can print my set. So this would give the values as 1, 2, 3, 4, and 5. And the interesting thing about set is I can say this as my set is equal to, put the curly brackets over here and say 1 comma 3 comma 5, 4, and 2. Let's say these are the values, and now I'm printing my set. So I'm just like creating a simple set and I'm printing it, right? So note what happens here. So I add the values 1, 3, 5, 4, and 2, but these values has been ordered as 1, 2, 3, 4, and 5. So this is another nature of set. So if you have like some values in it, right? So these values are going to be ordered when you're kind of printing it, or like when you're accessing it. So this is about the set. So let's say that you want to order a list that has like kind of values that are not ordered. You can just convert that list into a set, and that would kind of order the stuff there. So let's say that we have this list 1 as values like, let's say 5, 4, 2, 1, and 3. So these are the values, and now let's say that you want to order these values. So what you can do is you can just say that set1 is equal to, use the keyword set, and then pass this list1. So this is going to convert this list into a set. Print this set1. As you can see, now this list has been ordered, but if you want to convert this back to a list, you can say list2. So we are storing this in list2, but again you can use the same variable name list1 as well. So I'll say list2 is equal to list of set1. So what we are basically doing here is first converting a list to a set, and as this is a set, it's going to order these values, and then we are converting back to a list, and then you can print this by saying print list2. So this is like another operation that you can look at. So This is how you can start with an unordered list and you can order it using a set. You can also add values to the set, as sets are also a mutable data type. So here I'll say this as set is a mutable data type. So I can say let's maybe use this thing my set, or maybe I'll use these values that are ordered. Let's say my set is equal to 1 2 3 4 and 5, and maybe print that first. So it has the values 1 2 3 4 and 5, and let's also check the type. Class belongs to set, and now I can say my set dot add 6 in parentheses. So this is going to add the value 6 to the set my set, right? So we have 1 2 3 4 5 and 6. So this 6 has been added to this variable which has set my set, and we have added this value 6 to it. Similarly, you can delete the values as well. So for this you can say my set dot remove. Let's remove the value 2 and print my set. So now as you can see, the value 2 has been removed. So this is how you can edit the values. You can add some values to this, or you can kind of uh, delete some values to it. The other distinct characteristics about this set is that when I put my set of 0, you cannot access the values with index. So set doesn't have the concept of index, so you cannot access the individual values using any index. So when you try to do that, you would get a type error saying set object is not subscriptable, which basically means that we can't access the values using index. So that's like another distinct characteristic about this set. So these are the first three data types that we want to discuss, which is first is list, next one is tuple, and then we have discussed about set. So out of these, list and set are mutable, whereas tuple is immutable. And the other data type, the fourth data type that we are going to discuss, is a dictionary. So I'll say fourth one is dictionary. So out of these four data types, right, list and dictionary. So these two are something that you often use when you're working in general with Python. So you also use set and tuple once in a while, but when you in a comparative way, list and dictionary are like widely used, and in a lot of cases, dictionary is like a go-to data type where you want to like store some values with some key value pairs and so on. So I'll explain you what this looks like, and this is also a mutable data type. So here maybe I'll mention this as dictionaries are mutable. Okay, maybe I'll also put the keyword for each of this behind this. So list can be created with using this like keyword list. Tuple, again the same thing, we would have tuple all lowercase letter. Set is also same, SCT. And for dictionary, we can create it using the keyword dict. Okay, and then dictionaries are mutable, as I said. So dictionaries are like very different from whatever we have discussed, right? So we have list, tuple, set, which basically holds multiple values. We can access like, let's say, values with index in the case of uh, tuples and list, whereas the dictionary structure is slightly different. Let's say that I'm creating a variable and calling this as my dictionary. So my dictionary, or basically a dictionary also, is enclosed in curly brackets, right? Just like your set, but it would have a key value pair. So this is how it would look like. A dictionary would have a you know key and a value. So this value can be, maybe I'll put this without quotes. So it can be an integer or a float or a string as well. So it can have multiple key value pairs. Let's call this key 2. This is value 2. So this is how a dictionary would look like. Okay, I'll show you this. So here let's say that we have the values as name is Alice, and age of Alice is, let's say, 25. And let's say we have another, so this can also be an integer. Maybe I'll put this in an integer. It's not like we can have only string or float values or integer values. The values can be strings, you know, uh, integers, floats, and so on. So city is, let's say, New York. So this basically is a key value pair. So the first value that you're seeing, this name is a key, and the corresponding value for this key name is Alice. And here age is key and the value is 25. City is key, New York is my value. So now I'll print my dictionary. This is going to say name Alice, age 25, city New York. So this is how you can create a dictionary. And the other thing about dictionary is that you can have multiple key value pairs with the same value, but you cannot have the same keys. Let's say that I have this dictionary, right? So my dictionary, I can create a new key value pair. Let's say, let's call this as country, and in country I'm going to access this, or basically say that USA. Okay, so this is how you can add a key value pair to this. So I can say my dictionary, the name of the variable, in square bracket mention the new key that you want to create, which is country, and mention the value that you want to add. So when I run this and now print the dictionary, it's going to say the same thing, name, age, city, but we have added a new key value pair called as country USA. Now, if I add something like this, name is equal to, let's say John, and print this my dictionary, it cannot have two keys with the same name. So you already have name, so you cannot have another name here. So what you would see is this name is kind of replaced here. And this is also another way how you can edit certain values, right? So this is how you can create new key value pairs, and this is how you can edit values, but you cannot have two key value pairs where the key is same. But I can say something like this. Let's say that I'm creating a new key called as name 1, and the value is John. So in this case, the key is different. So this is name and this is name 1. So it's different. The values are same. So that's kind of allowed. But you cannot have two keys with the same name. So the first, when you do that, the value will be replaced. Or in other way, in other words, what we are basically doing is we are editing the value Alice to John. So that's what we are doing. So we cannot have like a dictionary with two same keys. So that's like another main thing. And as I said, we have already seen how you can access the values. Let's say that you want to find what's the age of the person that's present within this dictionary. So you can simply say print my dictionary, in quotes just mention the key that you for which you want to get the value. So when you call my dictionary of age, it's going to get this value and print it. So it looks into this my dictionary and looks at this key that we have passed, which is age, and give you the values. Okay, so this is how you can access it. If I want to access city, I can just like replace this age with city. So this is how you can access the values. And if you want to look at all the keys that's present in a dictionary, you can simply say print my dictionary dot keys. Don't forget to open and close your parenthesis. So it's print my dictionary dot keys and run this. So this is going to say dict keys, the dictionary keys that are name, age, city, country, and name. If you want to print the values that's present in the entire dictionary, so instead of keys, say values. Okay, so we have dict values. So this is dict keys, the dictionary keys, and this is the dict values. The dictionary values as John 25, New York, USA, and John. So this is how you can print like all the key and value pairs. And we have already discussed about like how we can kind of add new key value pairs to this, and how you can edit this. Maybe we can edit discuss about this edit once again as well. But before that, I'll tell you how you can delete a certain key value pair. Let's say that I want to delete this key value pair of USA, country USA. I'll maybe print this my dictionary again. And let's say that we want to delete this particular key value pair. So I can say del, delete, which is also a Python keyword. I can say my dictionary. So use this underscore here. And within square brackets in quotes, mention the key, which is country in this case. And then you can print my dictionary. So that's going to say name, age, city, and name one. So we have deleted this country. So if you want to edit certain values, right, we can just use the previous method that we have seen here. So here I can simply say my dictionary of name is equal to Alice, and I'm going to say my dictionary of age is equal to 35. So previously the name is John and the age is 25. So we are changing it with Alice and 35, and then we can print the dictionary as well. So when I run this, I get the values as name Alice, age 35. So these values, this John and 25 has been replaced with Alice and 35, and then we have the other values as it is city and name one. So this is how you can edit the values that we have already created, where we have this my dictionary, right? Just like a list or a set, the values and the values. In the case of list, it's values. In the case of dictionary, it's a key value pair. So those values can be changed by using this key name. Okay, so this is about the four sequential data types that we have in Python. So we have list, tuple, set, and dictionary, and we have also seen that list, set, and dictionary are mutable. That means you can change those values, whereas as tuple is kind of immutable. So set, list, and dictionary can be changed, whereas tuple cannot be changed. So these are about the basics of these four data types. So please practice this code, whatever I've given you, and in the next video, let's discuss about this concept of mutability and immutability. Thanks for watching. Hello everyone, I'm Siddharthan. This is the 15th topic in our complete Python course where we will be discussing about immutable and mutable data types. So the previous sections was about the different data types such as integers, floating points, strings, list, tuple, set, and dictionary. So some of these data types are immutable and some of these data types are mutable. So in this video, let's try to understand what is meant by this mutability and immutability and how this kind of changes the way that a data type kind of works. So this will be the agenda for today's video, and let's get started. So for programming, we'll be using Jupyter notebooks, and here I've just mentioned some definitions on like about immutability and mutability. So in Python, data types can be classified into two categories, immutable and mutable. And the main difference between them is whether an object can be changed after it is created. So that's what it means. So we have several data types, right? And some data types can be changed once it has been created. So those data types are called as mutable. So the ones that are changeable are called as mutable, and the ones that cannot be changed are called as immutable. So immutable objects, so these objects cannot be modified after creation. You can also think about this as data types instead of objects. So these objects cannot be modified after creation. Examples: integers, floats, strings, and tuples. So these data types cannot be changed, whereas the mutable objects such as list, dictionaries, and sets, these can be modified after creation. So in these data types, right, list, dictionaries, and sets, so once we have created these data types, we can edit values, add values, and even delete values. So that's the main difference between them. So now let's try to understand about each of these things individually. So let's start with immutable data types. So I'll create a text cell and put this in bold. And now let's start with, let's say, integer. So here I mentioned that integers are immutable, right? So let's see how that works. Let's say that we have a variable called as x, and then we are assigning the integer value 10 to this variable. Now I'm going to say y is equal to, even you can maybe print the type of x if you want, right? And after that I can say y is equal to x plus 5, and then print both x and y. So here we are adding the value 5 to this x value, right? So x is 10 and we are adding value 5 to this, and this is getting stored in y. So when I run this, we print that x is an integer data type, so it belongs to the class int, and x value is 10 and y value is 15. So when I add the value 5 to this is not changing the value of x, but rather it's adding value 5 to this x value and storing it in y, but the original integer value of 10 that's stored in this x is kind of not changed. So that's the main difference. When you say x plus 5, it's not editing the original data that has been created and that's stored in the variable x. So this is like one way of like looking at this immutability. And let's say that we have the value as 5, and now I say that x is equal to value 10, and when I print this, value of x in both these cases. First we are printing this x value and then we are changing this value to 10 and then we are printing this. Let's understand. So first both are like values represents the same variable name, that's x, but first we add the value 5 and then we add the value 10. But I said that you cannot change the values of integer, right? But there is a trick here. So when I say x is equal to 5, we are assigning a value 5 to this. And when I say x is equal to 10, I'm not editing this variable x. I'm creating a new variable with the same name as x and assigning a new value that is 10. So here we are not editing the value of x, but rather assigning a new value to this variable x. So that's the difference. So a variable, if it's an integer, it cannot be edited or changed, but it can be reassigned to a new value. So we cannot say that this is mutable, as we are not changing any values but just like reassigning some other values to this. So that's like the main difference between them. So this is similar to saying x plus equal to let's say x is equal to 10 and then x plus equal to another 10, or maybe I'll put this as 5. So this we have seen in the assignment operators in our previous videos. This is same as saying x is equal to x plus 5, right? So this means like to this value of x that is 10 and I'm adding the value 5 to this and then I'm printing this. So this is like the same concept. So here first we add the value of 10 and then to this x I'm adding 5 and I'm assigning this to a new variable with the same name x. Again, this doesn't count as editing, but this is like reassigning a value to this variable x. So this is about integers. You can reassign value to the variables that you have created, but you cannot edit the original value that has been created. So this is like similar to floating points and strings as well. So let's say that we have a float value. Let's say that this is for float. Again, float is also a immutable data type. So that means like you cannot change the value. If I say a is equal to 2.6 and let's say b is equal to a into, let's say, 10. So we are multiplying this a with 10, but this is not going to change the original value of a, but this will just multiply this and store this in the variable b, as you can see. So 2.6 is still 2.6, so we haven't like multiplied. So we have multiplied it but we have not changed it, but we have stored it in this variable b, so we are getting this value. So this kind of uh, the same for a string as well. Let's say that I'm creating a string with the variable name text and just putting a string called as Python programming. So here also, if I check the type of this text, it's going to say it's a string str, which is a string data type. I can access the individual letters of this string by saying text of 0. That means index of 0, and we have discussed about index as well. So when I say text of 0, this is the 0th element, this is the first element, and so on. So p represents index 0, y represents index 1, t represents index 2, and so on. This goes on, right? So when I say print text of 0, it's going to print the first letter because that's the index 0. But I cannot change this index values. I cannot say that text of 0 is equal to, let's say I want this p to be changed with z. When I do this, it's going to throw me an error. Oh, I have to put this in double quotes. So I'm trying to change this value p to y in the first letter. So that's going to say string object does not support item assignment. So once a string has been created, you cannot edit that original string value as it is immutable. You can make some changes to this. Let's say that I have let's say this text as Python programming. I can create a new variable called as result, which is equal to text plus, I'm putting a space here and say Python programming language. So here I'm adding this string, another string called as language to this text, but the difference is I'm not adding this to the original variable that we have created. So here I'm printing the text and I'm printing the result as well. So that's going to say Python programming and Python programming language. So that's about it, right? So this is how you can work with this data types such as integers, floats, strings, even tuples, where you cannot edit the values. You can like reassign values to the same variable, but you cannot edit the original value that has been created. So similarly, in the case of tuple, which we have discussed in the last video where we have discussed about list, tuple, set, and dictionary. So we know that we can create tuple with 1, 2, 3. That's basically values that are mentioned within the parenthesis, and you can print the type of this my tuple, and you can also print the tuple itself. That's going to say it belongs to the class tuple, and these are the values. You can print the individual values here by saying my tuple of 0. So that's going to print the first value, that is 1. So one belongs to index 0, this belongs to value belongs to the index 1, this is index 2, and so on, right? So when I say my tuple of 0, this is this value, but I cannot change this value. So I cannot say my tuple of 0 is equal to 10. So here I'm trying to change this value 1 with 10, and that's going to raise an error saying tuple object does not support item assignment. Whereas in the case of list, right, you can do this where if you have 5 elements or 10 elements, no matter like what is the number of elements that you have, you can change those values once the list has been created. So this original variable called, let's say that we have a variable called as my list. So the values will be edited in that original list. So that's how the mutable and immutable data types differ. So we have discussed about integers, floating points. The next one is about string, right? So I'll just put a comment here saying this is for string and this is for tuple. So now let's discuss about mutable uh, tuple. So mutable data types, that's nothing but list, dictionaries, and sets. Okay. So this is for mutable data types. So first let's discuss about list. So I'll put a comment and say this as list, and let's create a list by saying my list, which is equal to the same values 1, 2, 3, 4, and 5. And then I can print the data type of this my list. So we know that that's going to say it's a list data type, and then I'm going to print my list as well. So it's going to say it belongs to the class list and the values are 1, 2, 3, 4, and 5, right? So now previously we tried to access like some values and try to change it, right? Let's do the same thing. So I'm going to access the 0th value, which is 1. So I'm going to say my list print my list of 0. So that's going to give the value 1. Now I'm going to say my list of 0. So this value should be changed with the value 100. And then I'm going to print this my list. So here we are not reassigning a new list to this variable called as my list, but we are editing the list that has been already created. So now this 1 has been replaced with this 100, but this cannot be done with a tuple, as we can see this as raised an error. So that's why we say that lists are mutable data types. And you can kind of append values to this. I can say my list dot append, let's say 35. So and then print this my list, right? So we have added a value 35 to this list that's existing, right? So similarly I can also delete some values. Let's say that I say my list dot remove a number like let's say 3. So that's going to remove the value 3 from this list that we have over here. So I run this. Oh sorry, it should be REMOVE. So now we don't see that 3 anymore. So this is how you can edit the values in a list. So you can append a new value, you can change a value that's already present. So here we have changed 1 to 100, and then how you can remove a particular value. So that's about this list. So now let's see how sets are mutable. So this is the second example in the mutable data type. So these are set. So I can say my set is a variable that I'm creating. We know that it should be present in curly brackets. I can say 1, 2, 3, 4, and 5. Similarly 5 data points, and then we can print the type of my set. Let me copy this quickly, and let's print this my set as well. So it belongs to the class set, and we have the values as 1, 2, 3, 4, and 5. So now I can add a new value to this my set by saying my set dot add. Let's add the value 10 to this, and then print my set. So that's going to say 1, 2, 3, 4, and 5. So it has added a new value, but these are not possible in the case of tuple, as we cannot edit the tuple values. You can try that out there as well if you want. So if you want to remove a particular value, you can simply say my set dot same thing, same function, remove. So it's going to remove that particular value. So this is how you can edit the values that's present in a set. And the third example in the case of mutable objects is my dictionary, right? So we have seen how we can create dictionaries. So let's say that we are creating, maybe I'll just use a small variable name like a. So we are creating a dictionary called as a, and it has like key value pairs like name, let's say Alice, and second key value pair is age, which is let's say 30. Okay. So now I'm going to add a new key value pair to this. I can also print this A and also print the data type of A. That's going to say dictionary is like name Alice age 30 and it belongs to the class dictionary. So we know that it's an immutable data type, so we can change it. So in this original dictionary A, I'm going to add another key value pair. So for that I can say A square bracket create a new key value pair. Let's put city, and within the city I'm going to create the value as New York. So what we are doing here is, so similar to name and age, which represents the keys of this dictionary, I'm creating a new key called a city. To that, just like Alice and 30, I'm adding a new value, a string called as New York. And after that I can print this A, so that's going to add this. So this is how you can edit a dictionary that has been already created. So again, here we are not creating any new copies of this dictionary, but just like editing the dictionary that is already there. And if you want to edit a specific value, right, so let's say that I want to change this value 30 to something else, 40 or something, I can mention the key name, which is age here. So I can say A, within double quotes mention your key name, which is age in this case, and I can change this to 40 and then print your age. So that's going to change his age value, that is 30 to 40. So you can also delete a value by saying let's say delete a of age. So that's going to delete the key value pair, that is age, and I'll print this A. So that's going to say name and city. So we have deleted this age. So this is how you can edit a dictionary. So this is the main difference between immutable and mutable data types, and there may be cases where you want to use a data type that where you shouldn't change that data type later. In that case, you can go with immutable data types, like let's say tuple. But in some cases you want the data type to be changed, or you create that data type dynamically. In that case, if you want a sequence data type, you can go with a list or even maybe a set, right? And even dictionaries, we try to create those dynamically. List and dictionaries are kind of created dynamically in most cases. So this mutable data types come in handy in those cases. So this is about these two differences, where immutable objects or the immutable data types cannot be changed once it has been created. And the examples are integers, floats, strings, and tuples, and we have seen that example of how you cannot edit those values. You can create new variable with that same name, but still you cannot like edit the original values that you have given it. And mutable objects are the one where the original data can be modified in the same variable, right? For example, the case of list, set, and dictionary. So I hope that you have understood what we have discussed today. So this is like a very basic stuff, like it's not something that you explicitly use, but it's good to know about this. So I hope you have understood whatever we have covered, and that is all from my side for this video. I'll see you in the next upload. Thanks for watching. Hello everyone, I'm Siddharthan. This is the 16th topic in our complete Python course, where we will be discussing about list in Python. So we will be understanding the different functions and operations that we can do on list, and the different ways using which you can use a list, and what are all the use cases that we can work with. So this will be the agenda for today's video, and let's get started. So we have already had kind of an introductory session of understanding list, tuple, set, and dictionary, but I wanted to go in detail about list, and especially in dictionary in the subsequent videos, as these are kind of like important data types that we have in Python. So in this list topic, let's just start with a very simple example. So I'm going to name this as the first example that we are going to see. Here we are going to create a simple example of a list. So I'll call this my list. So we are creating a variable called as my list, and saying the list has the values like 1, 2, 3, 4, and 5. So these are the values. So when you use a square bracket for starting and towards the end, so it basically creates a list. If it's a parenthesis, that's going to be a tuple. So that's how you can distinguish these two. So when you use square bracket, so that's going to be your list, and when it's a tuple, it's going to be your parenthesis, and for curly brackets are used for set. So this is the list that we are creating, and now you can print this list by saying print my list. So that's going to print your list as the output. And you can also check the data type of this. So here I can say print type my list. So you may think that I already know that this is a list, and why I have to kind of check this, right? So you may have this question, but the thing is, when you're working on some projects or some use cases in some larger Python code, so sometimes you need to dynamically create this list, and sometimes you may not be sure what that particular data type is. It can be a tuple or a set, or it can be a list, and you want to understand what that data type is at that particular part of the code. So you can kind of use this print statements with this type, and that would like print and show you what that particular data type is. Again, you can do this with debug as well, but this is like the main use case of this type function. So here we have created a simple example of list that has like 5 values, and we have printed it, and we have also checked the type, and it says it belongs to the class list. So the next one is creating an empty list. So here I'll say empty list as the comment. So empty list is like often used when you're using a for loop to dynamically create a list, and also when you want to initiate a empty list and later add some values to this. So in those cases we kind of create these empty lists, and that can be done just by mentioning like opening square bracket and ending square bracket. So this is what a empty list is, and here I'm creating this for a variable called as a. So next I can say print a, and also print the data type of this. So I can say print type of a. So it's going to print just the square brackets, which doesn't have any value. So that's why we call this as an empty list, and it says it belongs to the class list, right? And you can also convert other data types to list. So let's say that this is convert to list. So let's say that, let me put this in comment. So let's say that a is equal to a tuple that has the values like 10, 20 and 30. So this has 3 values. So I have to convert this to a list. So I can say b is equal to, or first let's maybe print a, and then I'm going to say b is equal to list of a. You can also say a is equal to list of a, but I'll just save this in a different variable and also print this b. And in both cases, let's also print the type of a and b. So first it will be a tuple, okay, as it's enclosed in a parenthesis, and now it will be a list as we are using this list keyword to convert this tuple into a list, and then we are going to print the type of b. So it says first 10, 20 and 30 are enclosed in parentheses, and it says it belongs to the class tuple, and in the next case this has been converted to a list as we can see the square brackets here, and we can verify that by printing the type of this as well. So this is what converting tuples to list. So let me put this as convert tuple to list. Let's see how we can convert a set to list. So set should be enclosed within these curly braces, and I can run this. So it says 10, 20, 30. So it belongs to the class set, and now we have converted it to a list. So this is this third example of conversion. So first we have created a simple example of list, and also discussed about empty list, and next one is the conversion. So the fourth topic that we'll be discussing is like creating a list with mixed elements or mixed data types. So we don't have a restriction in Python for list that a list should contain only integer numbers like this, or it should contain float numbers, or it should contain string numbers at once. So we don't have any restrictions. So I can create a list, call that a, and say that has the values as 1 2 3.5, and it has like string value like Python, and values like true. Even I can create another list as its element. So let's say that 20, 30 and 40. So these are the values. So I have the values like 1 2 3.5 Python true and so on. So these two are integers, and then we have a float value, and then we have a string value, boolean value, and we have a list within that as well. So you can have list within a list, on, and you can also have like tuple within a list. So everything is like possible. So we don't have any restriction on like what's the data type that should be present. So in these cases we have list and tuples as elements of this list as well. So this is how you can create a list. So all you have to do is just like use those words, and again we don't have any restrictions on a uniform data type, like a single list should have only integers, or a single list should have a floating point value. So nothing is there. So you can have a list that has like mixed data types. So now let's see how we can access list elements. So this is the fifth topic that we are discussing. So this is accessing a list elements. In list you can also have duplicate values. So maybe I'll just quickly show this to you. So here I can have 1 comma 2 comma 2, and when I run this it's going to have that. But in the case of like data types like set, you cannot have like repeating values, right? So that's another difference between them. So in this fifth case where we are going to access list elements, so let's create a list as a and say 10 20 30 40 and 50. So this list has like 5 values. Let's see how we can access this. And we have already discussed about indexing, and we know that in Python indexing starts from 0, right? So I'll maybe put a text here. So I'm going to convert this to a markdown file and say in Python indexing start from 0. So what this means is you refer to this 10 as 0th element, this as the first element, this as the second element, and so on. So this is 0, this is 1, this is 2, and so on. So we start counting from 0. So if I want to access this particular value 20, right, so what I can do is say print a, which is the list name, and within the square bracket mention the index of the value that you want to print. So let's say that you want to print the second value. So first value has the index of 0 and second value has the index of 1, right? So I can just say 1. So that's going to print 20. So you have to mention the index, not the value, you have to mention the index. So if you want to print the first value, you would say print a of 0. So similarly, you can use this index to access like specific values of the list. So you can also say something like print a minus 1 within the square bracket. When you say minus 1, it's like from the reverse order. So minus 1 basically means this 50. So there are two ways to look at this. You can access this value 10 by using the index 0. The index for 20 is 1, this is 2, this is 3, and this is 4, right? You can also access this by saying this is minus 1 index, this is minus 2 index, minus 3 index, minus 4 index, minus 5 index. So maybe I'll show this to you. Maybe first I'll say a of 4, that's going to print the index fifth value, which is basically the index 4. And I can also print this by saying a of minus 1. So that's going to print this because minus 1 refers to the last value. So this is minus 1, minus 2, minus 3. Let's say that we want to print this 30. So what I can say is print a of minus 3. So that's going to print this number. So this is how you can access the list from the reverse order as well. So next topic that will be, so we have worked on this accessing. So the next thing that we will be discussing is slicing a list. So we have discussed about strings in detail, and we were discussing about this concept of string where you can cut a substring and you can print that, you can like play around with that, right? So the concept of slicing works with list as well. So that's what we'll be discussing. So I'm creating, let's say, a list called as again my list that has the values like the same thing. Maybe I can quickly copy this and paste. You can take any values. Just for simplicity, I'm taking these set of values. So let's say that these as 10, 20, 30, 40, 50, and 60. So I'm going to say print my list, and within the square brackets I'm going to say 1 colon 4. So when I say 1 colon 4, again we have discussed this. So when we mention the index like this, it's going to consider this value. So we have this starting index and then we have the ending index. So when you slice a string, right, so you mention list variable and you would mention start index and what's the end index that you want to print, right? So here I want to print from 1 and 4. So when you do that, your start index value included, whereas your end index value, this will be excluded. So what I mean by this is, so let me take this as 0 for simple explanation. So 0 means the value 10. So index of 10 is 0. This is 1, 2, 3, 4, and 5, so on, right? So when I say 0 colon 4, when I'm slicing this, the 0th value will be included. So this is 0, 1, 2, 3, and this is 4, right? So what you would expect is when you say 0 colon 4, it should print from 0, 1, 2, 3, and 4. So the 50 is the index 4. So you expect it to print it till 50. But what happens is it won't consider this end index. So when you say 0 colon 4, it starts from this 0th index but stop the way before this 4th index. So that's why I've said it as start index value is included, which is 0 in this case, 10 value 10. The end index value is 4, which is 50, so that will be excluded. So when you run this, you get the values like 10, 20, 30, 4, and then 40. So this is the distinction in this. And you can also say my list. So if you don't want to start from 0, the first value, if you want to start from the second value, the index of this value is 1, right? So you can say 1 colon 4. And that's going to print this as 20, 30, and 40. Now you can also say this something like print my list. You can just say colon 4. So when you say colon 4, when you don't mention any number, it's understood that it is 0. So this colon 4 is similar to saying 0 colon 4. So it's going to give you the same set of values that we have over here. So that's about it. And the other thing is we can also say print my list let's say 2. So 2 index 2 value is 10. So this is 0, 1 and 2. So this is going to start with 30 and print the entire list from there. So when you run this, so this is similar to saying, so the when you want to print this entire list, right? So you would say something like print my list, you know, 6. Not sure if 6 is the value. Yeah. So when you put 6, you are getting this entire list, right? So when you say 2 colon and you don't put anything, so that's like the maximum index value, like the maximum thing that you're going to. So in this case, like again, the another intricate thing is the index of this value is 5. So we have 10, 20, 30. So 0, 1, 2, 3, 4 and 5. But if I mention 5, that 50, 60 won't be included, right? Because this is the index 5, but that will be excluded. So we have to say last index plus 1. So the last index value is 5, so we add 1 to it and say we say 6, right? And you would get the entire list. And when you say 2 colon and just leave it as such, this is like putting the 6 in this case, which is like the number that's going to give you the rest of this list. So that's how you can remember this. So we have this 2 colon thing. So that's how you can slice the string. And the next thing that we can discuss is modifying list elements. So the previous video was about the immutability and mutability. So immutable data types are the ones those which you cannot change the values once you have created it. Say for example integers, floats, strings, tuple. And there are other kind of data types called as mutable data types. So these data types can be edited or modified once they have been created. So these are called mutable data types or mutable objects, and list is an example of mutable objects. So we can edit those values. So let's say that here I'm creating a list with this same set of values. I'm just like naming this as A, that has value as, let's say, 5 values, 10, 20, 30 and 40. And let's say that I want to change this first value. So maybe I'll first change this, print this A, and then I'll say a of 0. So when I say a of 0, it means this 10, right? Because 10 is of the index 0. So I can say a of 0 is equal to 99 and print this a. So first we add the values 10, 20, 30, 40 and 50, and using this index we have changed this 0th index value from 10 to 99 using this. So this is how you can modify a value. So if you want to, like, let's say change another value, let's say this 30 needs to be changed. The index of this 30 is 2. So I can mention 2. So that's going to say 20, 30, 40 and 50. So here we are recreating this a list, so that's why we don't see this 99 anymore. So we are creating this list newly, and then we are changing this third value with 99. So this is how you can modify the list elements. And the other thing is, now, so we have seen how we can edit a value. Now let's see how you can add new values to a list. So this would be adding new elements to a list. So if I have a list as a is equal to 10, 20, 30, 40 and 50, so I can say a dot append, I'll say 100. So when I say 100, the value 100 will be added to this list, and now I can print this a. So that's going to say 10, 20, 30, 40 and 50. You can again add like any data types. It's not like we can add only integers, as we know that list supports other data types as well. So here I can say a Python, which is a string. So that would add this string value to this list. Not only the strings, you can also add list to a list. So here I'm going to append a list that has values like 99 and let's say 100. So when I print this, as you can see, we are not adding this 99 and 100 separately, but we are adding this list to this list. So we have 10, 20, 30, 40, and this list has been appended. But what if you want to add this 99 and 100 as values to this? So in that case, so here we have used this method called as append. So instead you can say extend. So when you do this extend, so instead of adding this 99 and 100 as a list, this can be added as the individual element. So this will be unpacked and added like individually, 99 and 100. So this is how you can kind of like extend a list with another iterable data type like this, another list. So we have 10, 20, 30 and 40, 50. When you use append, this 99 and 100 which is present in a list, as you can see the square brackets here. So those will be added as a list, but when you do this extend, it's going to add those values individually. And you can also like merge two lists. I'll say that a is equal to 1, 2 and 5, and we have another list as 10, 3 and another 10. So if you want to, let's say, combine these two lists, you can say C is equal to A plus B. So A plus B basically joins the two lists that we have. Again, it won't order it or anything. It will just like stitch these two lists together and you can finally print your C. So we have 1, 2, 5, 10, 3 and 10. So this is how you can join two lists. So this is another example that I wanted to explain you. And we also have this insert method. So all these are coming under this modifying this list elements, right? So I'll not number this now. So we have this insert statement. So insert adds a value at a specific index. So I can say A is equal to 1, 2, 3, 4 and 5, and I'll print this A, and now I can say A dot insert 0 comma 100. We have two commas here, and then let's print this A. So we have the values as 100, 1, 2, 3, 4 and 5. So what I've done is I've used this insert method to add the value or insert the value 100 at a specific index that is 0. So the syntax for this is list that you're creating dot index is the method, and then you have to mention the index at which you want to add, index at which it should add. Maybe I'll just mention this as index and value you want to add. So in this case, we have created a list that has 5 values, and in the 0th index, we want to add another value called as 100. So this is different from the previous case, like this one where we are changing a value, but in this case, we are not changing any values. We are just like inserting another value to this. You can also do this by saying, let's say 2. So you have 0, 1 and 2, right? So in this 2 index value, we are going to insert this 100 value. So you have the values as 1, 2 and 100. Now 100 takes that index of 2 rather than 3, and then we have the values, but we haven't like deleted that value 3. So this is this example. So like this is how we can use this insert. So this is 6, 7 and 8. Let's consider like all these are related to adding new elements to this list. So in this case, we have used this extend, right? So now I'll say 8 one is removing values from a list. So first we are going to discuss about remove method. I think this we have already discussed, but that's okay. So I'll say A is equal to 1, 2, 3, 4 and 5. And first you can print this A, and then you can say A dot remove 4 and print this. So this is going to remove the value 4 from this, and now that will be edited in that original list of A. So here we are not creating a new copy of A. We are just like editing the original variable that we have created with this list 1, 2, 3, 4 and 5. I'm saying remove the value 4, and then we are printing it, and now we are not seeing that 4 anymore. So this is one way to do this. We also have like an interesting method called as pop. So I'll say pop method. So when you can just like copy this, maybe I'll just create this new one and say val or value is equal to a dot pop and print this value and also print a. Let's see what happens here. So when you do this a dot pop, that's going to remove the last value from that list, and that removed value will be stored in the variable value. So the variable that you're creating for this a dot pop. So there are two things that are happening here. One is this list A has been edited where we are removing the last value, but we are not discarding that value. So that value has been stored in a different variable. In the previous case, we are just like removing a particular value, right? But it's not stored anywhere. But in the case of pop, we are storing it. And as this pop has the ability to remove the values at the last, there is like a different data type in programming called as stack, where you can only add values on top of the other. Like you cannot insert any values, and if you want to remove any values, you can just remove the last value. It's just like a stack of plates. If there are a stack of plates, you put one plate on top of other, and if you want to remove, if you want to properly remove, you take the top plate first and the other plate and the other plate. So similarly, you can remove this 5 first, and then using this pop method you can remove this 4 first. So in Python we don't have this data type called a stack, but we can create a stack like data type using this pop method along with list. So when you don't mention anything here, so this pop method is going to remove the last value. But there is also another way to use this pop method. So if you don't want to remove the last value, you want to remove this value 4. You don't have to mention 4 here, you have to mention the index. Maybe for this I'll take the example of 10, 20, 30, 40, and 50, as the index value can be a bit confusing. So let's say that we want to remove this value and store it. So previously we were not like storing it using this remove, right? But let's say you want to remove this value and store it. Look at this index. So this index is 0, 1, 2, and 3 is index, right? So within this pop mention 3 and run this. So that's going to remove the value that's present in index 3, that is 40, and that's going to be stored in this variable called as value. So this is how you can remove values based on index and store it somewhere. And now let's say that you just want to delete it and you don't want to store this 40 anywhere. In that case, you can do something like this. So create a list, and this is delete method. So the keyword is delete. So create this a list and say del a of, let's say, 1, and then print this a. So here we are deleting the index also based on the index we are deleting the value. So when I say a of 1, it's nothing but this is index 0, this is index 1. This 20 will be removed and we would get the value as 10, 30, 40, and 50. So this is how the values can be removed from a list. So the next thing that we will be discussing is using for loop along with list. So I'll say again, there are like several things that we can do with a list and a for loop. First, let's see how we can create a list with a for loop. So instead of assigning the values at start, so you can dynamically create some values. So this is for creating a list using for loop. So let's, for this, as I said, we will be initiating this variable a as an empty list and say for I in range, let's say 0 to 10, a dot append I, and finally print this a. Let's understand this. So this is similar to index as we have discussed already. So the starting index value 0 will be included and this 10 will be excluded. So you would have, so that you would have the values from 0, 1, 2, 3 all the way up to 9. So let's run this and see. So what happens here is when the for loop runs for the first time, I takes the value of 0 and this value has been appended to this list A, right? And in the next step, I takes the value of 1 and that one has been appended to this list that already has 1 in it. Maybe I'll print this and show you, that would make better sense. So first we are printing I, we are appending this in this, and finally printing this, and final list, let's print within, some markers. I'm going to say 30. So this is going to print this iPhone 30 times, and just like copy this and paste it over here. Let's understand this. So what happens is, maybe here also I'll put a marker. Okay, let's understand this. So this is what happens when the for loop runs for the first time. So I take the value of 0. So we are printing this I, and this value I, which is 0 in the first case, is appended to this empty list A. So now this list A has been changed to a list that has value 0, right? And now the second time the for loop runs, the second time the value I takes the value of 1. That's what we have printed this, and this is appended to this list A. Now the list A is not empty, it already has the value 0. So now we add 0 and 1. The next time 2 is the value of I and it's get appended, and this process goes on until value 9. This is because, as I said, the starting index will be included, this ending index won't be included, so you would get the values from 0 to 9. So that's why you're seeing the values from 0 to 9 in the final list. So maybe I'll just like copy this entire same thing and put this without any print statements in between so that it looks clean. So this is how you can create a list dynamically using for loop. Let's say that we want to do this, and again you can also say this 1 comma 10, or if you want the values between 1 and 10, you can say 1 comma 11. So 1 will be included and this 11 will be excluded. So you would get the values from 1 to 10. So this is the values. So what if you want all the two multiples of 2? So you can simply say same thing, but just instead of adding this I, I'm going to multiply this with 2. So before adding this value to this list, it's going to multiply that value with 2. So it's just like doing the same thing, but before appending this 1 will be multiplied with 2 and you get the value 2 here. So 2 is multiplied with again 2 and you get the value 4 here. So all these individual values that we unpack from this range, keyword range, are multiplied with 2. So this is how you can create this. And there is an interesting concept called as list comprehension that's going to let us easily create list using this for loop. So here we have seen, right? So this is how you simply create a for loop and then create a list that has values from 1 to 10, right? That is like, let's say, as 1 2 3 and 4, 3 lines basically. Now instead you can just do this in a single line, saying a is equal to, open the square brackets, say I for I in range 1 comma 10. This is all that's going to take. So let's print this and check this once. So it has the values from 0 to 9, as we have mentioned 10. If you want the value 10, you can change this to 1 and 11. So what happens here is it's just like the same thing, but we are writing this in a single line. So when I say I for I in range 1 to 11, so this for loop is going to run these many number of times. So I takes the value 1 for the first time and all the way up to 10. And we are just putting all this in a square bracket. So this is what happens. So we create a list that has the values from this 1 to 11. Again, if you want to have all the multiples of 2, just multiply this I value. So this I value that you're mentioning over here at the first, right? So this is just similar to appending this. So this append step happens because we put this I over here. So if you want to create values in the list with multiples of 2, just like multiply this I with 2 and you would get the values as 2 4 6 8 10 12 and so on. Okay. And if you want to, let's say, have squares, again that's simple, just put another asterisk. So this now becomes I power 2, so I exponent 2, so you would get 1 square, 2 square, 3 square and so on. So this is how you can use list comprehension to create list dynamically with some dynamic values in it. So the next step is, so here we have used a for loop to create a list. Now how you can iterate over a list, so let's discuss that. So this is the 10th example, right? 11th one is iterating through a list. So let's say that a has the values 1 2 3 4 and 5. I can say for, maybe instead of 5 I'll say val, or which stands for value. For val in a, print a. So in this case what happens is, oh sorry, I have to print val. So we are not iterating it over range, rather we are iterating over this list. So when the for loop runs for the first time, val takes the value 1. When it runs for the second time, val takes the value 2, and we are printing it at each step. So the third time it takes the value 3 4 and 5 and so on. If you want to, let's say, print all these numbers multiplied with 10, just like mentioned, val into 10. So each time it takes like individual values of this list, multiply this with 10. So if you want to create another list that has these values, you can say b is equal to, again, an empty list. So here you can just say b dot append val into 10. So now you're going to have two lists. The first list has the values 1 2 3 4 and 5, and the second list is going to have the values where it's corresponding to this list but has the all the 10 multiples. So when I print this outside the list, so print your list outside the for loop, because when you put this inside the for loop, at each iteration it's going to print the list, and you can see how it changes dynamically. But if you want to see the end result, just put it outside this for loop. So this is list A, and now we have another list called as B, and that has values that are multiples of 10. So this is how you can iterate a list through a for loop. We'll put the simple example in the first place. This we are creating another list, right? So here I'll just say 1 2 3 4 and 5 and say for val in a. Again, this val can be I. It's not like this is like any variable name that you can create. So you don't have to say that you can only have I or val or anything in it. Now I'll print val. So this is a for loop and list go hand in hand. Again, there are few more complex stuff that we can try there, but let's discuss that when we are at the point where we are discussing about for loop. So these are some basic example, and I hope that by this point you know that the purpose of this for loop is to perform a task again and again a specific task. In this case, we just want to perform the same task again and again, which is like multiplying it with 10. So instead of manually doing that with 10 lines of code, we or 5 lines of code in this case, as we have 5 elements, we have used a for loop to do this. So that's the purpose of for loop. Let's discuss about for loop when we get that. So don't worry about it. So this is another example. So the last concept that we are going to discuss is list methods or the list operations or the functions. You can call it anything, but the correct way to say this is list methods. So let's say that we have a list that has values, the same set of values. Let's say 1, 2, 3, 4, and 5. There are certain methods or the functions you can use along with this. So there is a method called as len, which stands for length. And when you use this length, it's going to tell you how many values are present in this list. So it says 5. So here don't mix this up with the index concept. So here we don't consider that indexing with 0. So that's not about it, this length. So length is just like counting, normal counting. So it counts the total number of values that's present in a list. So here we have 5 values, right? So it says there are 5 values in it. And then there is a concept of copy. So you can say b is equal to a dot copy. So that's going to create a new copy for this list and store this in a new variable called as b. And now you can print this a and then you can print this b as well. So b is like a copy of a, right? So there are like few other things as well. So let's say that we have a value, something like this. We have a list that is like kind of unsorted. So it's like not in order. So you can say a dot sort. Yeah, don't have to mention anything. So this original list will be sorted. I can say print. Okay. So this would sort the values. We have 5, 3, 4, 1, 2. So this sort is this inbuilt function or the method that we have with list objects. So that's going to sort the values. There is also another thing that we can discuss called as reverse. So this is not going to reverse this. It will just like reverse. It's sorry. It's not going to put this in descending order. It's just going to reverse whatever you have passed to it. So we have 5, 3, 4, 1, 2, right? So when you reverse this list, you would get the values as 2, 1, 4, 3, and 5, right? So not in order, but just like a reverse of the original list that you're creating. So the sort is used to arrange orders in ascending order. This reverse is used to just reverse whatever list that you have passed to it. And then you have something like this. So I'll copy this list A and say print sum of a. So that's going to give you the sum of all the individual values that we have in a list. So if you, let's say there is a list that has like hundreds of values and you want to count the values individually, so you can just use this sum method. And then you have this other things as well. So say min of a, so that's going to give you the minimum value, which is 1. You can say max, sorry, so it should be max of a, that's going to give the maximum value, that is 5. So these are some of the interesting list operations and the methods that you can do. There are like few others as well, so you can explore that, but this is like enough for now. So later when we work on more use cases and stuff in Python, let's explore those aspects as well, but these are like good to start. So here we have started with just considering a simple example of list. So you can create a list. We know that it's in square brackets, check the type and so on. We have also seen how to create a empty list. Just put two square brackets, and then we have seen about converting one data type to another, one data type to a list, let's say a tuple to list and set to list, and then mixer data types. How you can have a list that has like different data types in it, and how to access specific values using the index value. And next is like slice specific strings and like have a sub list, maybe we can call that. So I have like specific values from this original list, and we have also seen how you can modify the values in the list, as this is like a mutable object, and also add new elements and like append, and also about to extend the difference between these two, and how to join to list, insert method to insert at specific index, and also remove pop, which is going to be really helpful for us, and delete method for removing the values, and how to use for loop along with this list. So we have created the list using for loops in different methods with multiples of 2, powers of 2, and so on. And we have also discussed about this interesting concept of list comprehension, where you can create a list in a single line of code, right, using for loop, and then iterating over a list. And finally we discussed about this list methods. So I hope that everyone is clear about the concepts that we have discussed. So please practice this code. So maybe a bit confusing at start, but once you practice this like a few times, right, so you will definitely get this. So that is all from my side for this video. I'll see you in the next upload. Thanks for watching. Hello everyone, I'm Siddharthan. This is the 17th topic in our complete Python course where we will be discussing about tuples in Python. So the previous videos was about the topics such as the different data types that we have in Python, such as integers, floating points, etc. And we have also discussed about list, set, dictionary, which are sequence data types, and we have also discussed about list in detail. So in this particular section, let's dive a bit deeper into tuples in Python. So let's get started. And for coding, I will be using Jupyter Notebook as my environment. So this is about tuples. Tuples are immutable sequences in Python. So immutable sequence in the sense sequence basically represents a array kind of a data type where you can have like multiple elements in that. Say for example, list can have multiple values in it, right? So that's what we mean by sequence. And tuples are immutable. So this we have discussed already, where mutability means you can edit a particular data type, say a list or a set or a dictionary, whereas immutable data types are the ones which cannot be edited once they have been created. For example, integers, floats, tuples, etc. And unlike list, once you create a tuple, you cannot change its content, making them useful for fixed collection of items. So this we have discussed that in tuple you cannot change its constant contents just like a list, right? And this makes them useful for fixed collection of items. So what this means is like in some use cases in your code, if you want to have if you want to create a particular data type which shouldn't be changed, let's say kind of a list of elements, but you don't want that list to be altered later, then you can opt for tuple, as tuples are immutable. So this is like a basic definition of tuple. Let's just understand it with some examples. So the first thing that we are going to understand is a simple example of tuple. So I'll create a variable as my tuple and say parenthesis 1 comma 2 comma 3 comma 4 comma 5. Okay, so we know that lists are enclosed within square brackets, set and dictionaries are enclosed within curly braces, whereas tuples are enclosed within these brackets or parentheses, right? And once you create this tuple, you can print this tuple, and you can also print the type of this tuple by saying print type of my tuple. So I'll say type of my tuple. So this is going to say this as 1, 2, 3, 4, and 5, which are the elements of the tuple, and it says class tuple. So it basically belongs to the class tuple. So this is how you can create a tuple with a set of values, and then you can print it along with its type. And then the next thing that we can discuss is an empty tuple. So we have discussed in the previous section of how you can create empty list, and empty tuple is like pretty much similar to that. So I'll call this empty tuple, and let's name this as empty underscore tuple. This name can be anything. Just for convenience, I'll call this empty tuple is equal to just open and close your parenthesis, and then you can print your empty tuple and then print the type of this empty tuple. So now this is going to print this empty tuple that we have initiated over here, and then we are going to print the type as tuple. So now we just have like opening and closing parentheses, and we don't have any values in it, and it says it belongs to the class tuple. So this is how we can initiate a empty tuple in Python. The next thing that we can discuss is the third one is tuple conversion. Okay, so in this, let's understand how we can convert one data type into another. So basically, how you can convert a list or a set to a tuple, or tuple to a list, like basically those conversions. Let's create a variable as a, and let's say that is a list that contains the values as 1, 2, and 3. Now I'll print this a, and I'll also print this type of a, the data type of a. So it's going to say the list is 1, 2, and 3, and it belongs to the class list, right? So now you can do this conversion by saying, let's say b is the new tuple that we want to create with this list. So I can say b is equal to tuple, which is a keyword in Python. So you can see it turn green color, right? So this is a keyword, so that's going to convert the data type that's present within this. So I can say a tuple of a. So now this is going to convert this data type a, which is a list, into tuple. So this original a won't be altered, but this would be converted into a tuple and be saved in this b. So that's the process here. And now again you can just print b and also print the type of b, and you would get something like this. So first we have printed the list along with its data type in these two lines, and then we have you know converted this list into a tuple. As you can see, first it was in square bracket, now it's present in parenthesis, and we have also printed the data type that says tuple now. So this is how you can convert a list into a tuple. So in the next example, let's see. we can convert a set into a tuple. So it is also like exactly same. The only difference is that we have to create a set now. So we know that sets should be enclosed within curly braces, right? So I'll put this in curly braces, and other things you can just leave it as such. So first we print the set A in this particular line, and using this line we are printing the data type, and it says it belongs to the class set. And in the next step we are converting this set into a tuple, again using that same keyword tuple, and then we are just printing this tuple. So initially it was in curly braces, and now we have converted it, you know, as a tuple, and we have stored it in the variable b. So this is how different data types can be converted into tuple. So the other variation that we are going to see is how you can convert, let's say, a list into a tuple. So I'll say this as list to tuple, sorry, a tuple to list. So that we have discussed already. So there should be tuple to list. So here I'll say a is equal to, I'll mention this in parentheses, I'll say 10, 20 and 30. So these are the three values that we have. And first let's print a and also the data type of a using this. And finally I can say b is equal to list of a, and then print b and print type of b. So first we have created a tuple here as say we are printing this and also the data type, and now this has been converted into a list using the keyword list, and now you can see that it starts and ends with a square bracket, and it says it belongs to the class list. So this is how you can convert, let's say, a list into a tuple, or a set into a tuple, or a tuple into a list. So these are like some of the conversions that we can work with. So the next thing that we can discuss now is indexing. So indexing we have discussed in detail about this in the string videos as well as like the list video, and tuple indexing is also pretty much like similar to that. So I'll say tuple indexing. Indexing is nothing but like accessing the elements of the tuple or set or different data types, right? It can be strings or a, you know, list or a tuple. So we can access that using those index values. So let's say that e is equal to this particular tuple, and I'll just add like few other data points or values to this: 10, 20, 30, 40 and 50. So this has like 5 values in it, right? So this is the tuple. Let's print this and see. So we have these 5 values. So now let's say that you want to access the first element, that is 10. So what you would say is, you would say a square bracket of 0. So this means give me the value that's present in the index 0. And as we have discussed several times that in Python indexing starts with 0, so you count it as like 0, 1, 2, 3, and so on. So this is like different from counting the length. So you shouldn't like mix those two things. So just for indexing, it starts with 0. So 10 is kind of present in the index of 0, 20 is present in the index of 1, and so on. So if I just like, write an index of all these values, right, present in this 10, so it would look something like this. So we have a tuple, let's say this is of index 0, this of index, let's say 1, 2, 3 and 4. So this is like the corresponding index values for all these values. So when I say a of 0, so this would give this particular value, and this value is nothing but my 10. So I'll run this. So it says the value is 10. So if you want, let's say, print a of maybe 1. So a of 1 is like index value 1, that represents the value 20. So you get the value 20. You can also say this index as something like this, -1, -2. So this you can access in the reverse order, -3, -4 and -5, right? So this is also another way of representing this. So a of -1 or index -1 represents the last value 50. So it's just like reverse order. Now you don't have a 0, right? So you say that -1 is like this number 50, -2 is 40, -3 is 30 and so on. So if I just say print of -1, that's going to give the value as, oh sorry, print a of -1. So a of -1, where a is the tuple that we have created, says 50. And if you want to print this again 10, but with this particular index, you say a of -5. Let's say print a of -5, and that's going to give the value as 10. So this is how you can access the individual values of a tuple using this, and you can also slice tuples as well, just like a list. Again, we are not editing this, we are just like looking at like specific slices of this tuple, so it's not like we are editing this original tuple, so we have to sure about that particular distinction. So I can say something like a of 0 is to 3. So when I say 0 is to 3, it's again we have discussed that when we use this slicing, the first index value represented by the first index value is represented, this index value is not represented. Like basically when you say 0 colon 3, so you would print this value and this value, so we won't print that ending index. So you start with 0, you end before this 3, so you would say 0 1 and 2, so that would correspond to 10 20 and 30. So this ending index of 3 that we have represented here won't be included, as you can see here, right? If you want to print the entire values of the tuple, you can just say 0 colon and just like leave the other number as it is. So when you say this, it's going to print like all the values of this tuple, like starting from 0. Now if you want to start from this second index value and print the second index value, that is 1, and print the entire values of the tuple from there, let's say 20 30 40 and 50, in that case you can simply say a1 and colon, just leave the other number as such. So it would start with the value that start with index 1, and when you don't put any values, it's going to print the entire value. So that's how we can slice the tuple. Again, there are like different variations that we can try with step. So we can add like another value that would step or basically skip a particular value at each step. You can try all those things. So we have done that with strings and maybe with list. You can just like try all those different variation for yourself, so that would be like a good exercise for you. So that's about this indexing and slicing. Next, let's see how we can create this nested tuples. Nested tuples nothing but how you can just put tuples within tuples. So I'll say a is equal to a tuple, and that as like other tuples. Let's say it has two tuples. In this case, I just like created two empty tuples, and let's say that it has values like 1 2 and 3, and this has the values as 10 20 and 30. Okay, maybe I'll just take different numbers. I'll take this as 100 200 and 300, so that it's not confused with the index values. So let's say that this is our tuple. So in this case, the overall variable, this a is a tuple, and it has like two other tuples as its values. So when I print this a, it's going to give this values as the first tuple and the second tuple. If you want to access the first tuple, you just say a of 0, right? Print a of 0. So this is going to print the first tuple, that is 100 200 300. So this entire thing is the first element. 100 is not the first element. 100 is the first element of this inside tuple, the nested tuple. But for this variable a or this tuple a, this entire list is the first element. This list is the second element. So basically a has two elements in it. So when you run this, it's going to give you this entire thing. If you want to print the first value within this nested tuple, you can say something like this: a of 0 of 0. So this is because, so first we are separating this first element, that is 100 200 300, and from this tuple we are accessing the first element. Now if you want to access this 300, you would say something like this: print a of 0. 2 is the index within this list. So first indexing, again 0 1 2 3 corresponds to this entire tuple. So you have 0 and 1. So this represents index 0 and this represents index 1, right? And now within this represents 0, this represents 1, and this represents 2. So I put this as a 0 of 2. So that's going to say 300. So this is how you can create nested tuples and access the individual values of those tuples as well. So similar to this nested tuples, you can also have a tuple with different data types. So we don't have a restriction on saying that if you have a tuple, all the elements should be a list, or all the elements should be integers, floating point, or something like that. So it can have like any data points that's applicable in Python. So I can say a is equal to something like this: 10 4.5. So 10 is an integer, 4.5 is a float, and then we have a boolean value, and then again you can have a tuple value as we have discussed, and then you can have a list 9 8 comma 10. So we have a list and so on. And when I print this, oh sorry, so I should put a comma here. So we have this tuple that has like a mixed data types in it. So this is how you can like work with different variations of this tuple. And the other main characteristic of tuple and the difference between tuple and list is that tuples are immutable, right? That means you cannot edit the original tuple that you have created. So in this case, let's say that I create a tuple as a is equal to, we'll put this as 6th example, right? This is, yeah. So I'll say sixth is about tuples are immutable. So let's say that A is a tuple that has values 10, 20, and 30, right? And now when it's a list, when it's in square brackets, right, we can edit the first value by saying A of 0 is equal to 100. So here what I'm saying is, like, take the first value, which is represented by this index 0, which is nothing but this 10, and we are assigning the value 100 to this. So we are editing that value. So this is applicable in the case of list because lists are mutable. So once you have created a list like this, you can edit the values. But in the case of tuples, we cannot edit the values as they are immutable. So when I run this, I'm going to get a error saying that tuple object does not support item assignment. So you cannot edit the values once the tuple has been created. So that's about it. So these are like the examples that I wanted to discuss, and the last thing that I wanted to explain you about, like some of the basic methods or the functions that we can use on top of this objects called as tuple. So this would be tuple methods, and let's start with count. This is an interesting, method. So let's say that we have a tuple called as a, and this has the values as 10, 20, again 10 is present, 30, 40, again 10 is present, 50, 60, and so on. So we have like some set of values, and at a particular value is repeated, right? Here 10 is repeated, let's say 3 times, and maybe let's repeat 20 one more time. So basically 10 is repeated 3 times and 20 is repeated 2 times. Now you can say print a dot count of 10. So A is the tuple, right? So A is the tuple that we have created, and count of 10. So this is going to count how many times a particular number has been repeated in a particular tuple. So that's kind of given by this A dot count. So if the code is right, it should say 3 because 10 is repeated 3 times here. So it says 3. So this is how you can count repetition of values in a tuple. If I put 20, it should say 2 because 20 is repeated 2 times. So this is like one example method of tuple. And the other thing that we can discuss is index. Again, index is like pretty simple. So now I'll just like remove this repeated values, maybe, as it's not ideal in this case. So we have like, let's say, 5 values: 10, 20, 30, 40, and 50. So these are the 5 values. So now I can say index of 10 and index of 20. So this is going to give me the index value of the value 10 and index value of the value 20. So let's say that you have a large tuple and you want to exactly know like what's the index of a particular value. You can use the method or the function called as index, which is represented by this tuple dot index. So here is the tuple. So I'm saying this tuple dot index of 10. So the first print statement should print me the value 0 because 0 is the index of 10, and 20 is this should print 1 as the value, right? Maybe I'll put 30, so it should say 2. And when 10 is repeated multiple times, it would just like give you the first index. So even if 10 is like multiple 10 times, it would give you the first index, that is 0. So now I'll run this. So it says 0 and 2 because index of 10 is 0, this is 1, and this is 2. So the index of 30 is 2, and that's how you can do this. And the final thing that I wanted to discuss is like the length function. Again, this is not just common to list. This we can do it with, even with a string or a list, and that is printing the length of a tuple. So we have this length of tuple as, 8, right? So yeah, that's how we can print this. So length basically gives you the count. And here we don't do that indexing count. We just like count with 1, 2, 3, and so on. So it's just like the actual number of values that's present in a tuple. And the other thing is you can also work with the for loop in tuple. We'll just end with that for loop with tuple. So I'll say a is equal to 10. Sorry, let's consider this example. A is equal to 10, 20, 30, 40, 50, and so on. So for val in A, print val. So at each iteration, so we are iterating over this tuple, and at each iteration to take like one value. So when the for loop runs for the first time, it will print 10, and when the for loop runs for the second time, it will print 20, 30, 40, and so on. So here we have this simple for loop that we have created where we are iterating over a tuple. So and then you can just like do more things like this. So you can like multiply these values with 2 and kind of print it. And the other variation that you can do is like you can create a empty list and kind of keep appending this multiples of 2 of all these values and then create a new list with this. So these are like some of the example. Again, try some variations with for loop, but these are like some of the basic examples that we can use in order to understand tuples better. So the main thing with tuples is that its main characteristic and the difference between a list is that these are immutable. So once you create a tuple, you cannot edit those values. You can, you know, assign a part of this tuple, slice this, and assign that sub tuple to a different variable, but you cannot edit that original tuple that you have created. And then we have discussed about this empty tuple, for loop, the tuple conversions, and how to convert two tuple and from other data type to tuple, like all those things, and also indexing. So just like a string or a list, how you can index tuples. The other topic is of course the nested tuples and how you can access the values of the nested tuples and so on. And we have seen like how to create tuples with different data types. And we have also considered an example of immutability of tuples and also like few simple methods such as count, index, length, and so on. And finally, we have just like created some simple for loops that would iterate over tuples. So that is all from my side, and I hope that you have understood all the things that's covered here. So please try this code and let me know if you have any doubts. So I'll see you in the next upload. Thanks for watching. Hello everyone, I'm Siddharthan. This is the 18th topic in our complete Python course where we will be discussing about set in Python. The previous topics were about the data types like list, tuple. So we have seen what is meant by these data types, and we have also discussed about these data types in detail. So similarly, let's understand about set, characteristics of set, and what are all some of the operations that we can perform on top of set. So this will be the agenda for today's video, and let's get started. So I will be doing my coding part in Jupyter Notebook environment. So feel free to use IDE or notebook of your choice. So the first example or the first thing that we are going to do is just create a simple set. So here I'll write a comment saying creating a set. I'll maybe create another text cell. So select markdown here. So this is a text cell now, and move this up and just write set in bold. So first we are going to create a set. So for this I'm going to declare a variable called as my set and say curly braces 1, 2, 3, 4 and 5. A set is enclosed within a curly braces. So if you think about a list, it's enclosed within square brackets. A tuple is enclosed within parentheses. But sets and dictionaries are enclosed within curly braces, right? So dictionary we will discuss later, but for now you can just understand that sets are enclosed within curly braces. So here I've created a variable called as myset. Again, it's not mandatory that this should be the exact variable that you should use. Just for convenience and ease of understanding, I've used this as myset, but you can use shorter variables like A, B, C or something like that. So here we are declaring a variable and assigning the set values to this. And now I'm printing this as print my set. So this is going to print the set that we have created. And I also want to print the data type of this. So print type of my set, which is going to give me the data type of this variable my set. So it says the set value was 1, 2, 3, 4 and 5 present in line number 3. And then we have also printed data type of this my set in line number 4, and it says set class or object set. So this is the first step. Now let's see how you can create a set using the set method. So I'll say use set method to create a set. So this is not only to create a set, but it is also helpful to convert one data type like a list or a tuple to set as well. So that's like another interesting use of this. So let's say that I have a list called as my list, and it has values like 1, 2 and 3. So these are the three values. Just maybe again, let's say that we have 2 and 1. Okay, so these are the 5 values. So we have 1, 2, 3, 2 and 1. Or maybe I'll just put this 1 and 2, and these are the set of values, and we can say that 1 and 2 are repeated here. So 1 and 2 appear like 2 times in this particular list, and list allows duplicate values, right? But in the case of set doesn't allow duplicate values, but let's come to that later. So here I'll print my list, and I'll also print the data type of this my list saying type of my list. So this is going to print our list as this is in square bracket. That's why I'm calling it as a list, and we are also cross checking this by printing the data type of this my list. So it says list is 1, 2, 3, 1, 2. As you can see, it has the duplicate values that we have assigned, and it says it belongs to the data type list. So now I just want to create a distinction. So I'll just put a hyphen in this quotes and put an asterisk sign and say 30. So what this is going to do is print this hyphen 30 times so that I can like print all these things below this hyphen so that you see a clear distinction between the first two print statements and the other two print statements. Again, this is not mandatory, just to have a visual distinction between them. Now I'll create another variable and I'll call this as my set. And I'm going to use the set method, which is a keyword in Python, which is used to create sets or convert one data type into set. So inside this set method, I'm going to pass my list. And now I can print the set that I've created, which is my set, and also make sure the data type is proper. So what we are doing is this set method takes in some sequential data types, like let's say a list or a tuple, and it's going to convert that into a set. And that converted set is stored in this variable called as myset. And then we are printing this myset, and we are also printing the data type of this myset. So when I run this, you can see the set has been created, but the other interesting thing is that the duplicate values 1 and 2 these values have been removed. This is because set doesn't allow duplicate values to be present in it. So this is the use of this set method, where one is it's used to create a set, and the other one is like it's used to convert one data type, like let's say a list, into a set. So this is like one way to use this. The other way to use this is like, again, just like what we have done here. The simple change is that instead of assigning this to the variable, you can just, instead of saving this in a variable and giving out some memory, you can directly assign a list here. So I can say my set is equal to set of 1, 2, and 3 and 4. So pay close attention that I've mentioned this within a square bracket. So I didn't just say that, I didn't write this without these square brackets. So this should not be done. So it should be present, let's say, within a list, and that's going to convert that into a set. So this is how you can use the set method in order to create a set or to convert like other data types into set. So that's other thing. Now the third thing that we are going to do here is creating an empty set. So this is again a interesting thing, because this is like slightly different from what we have done with a tuple or a list. So this is about creating an empty set. In list, like what we did is, like let's say if you want to create an empty list, you would just say a is equal to square brackets, and if you want to create an empty tuple, you would just say b is equal to parenthesis, right? But you cannot say a is equal to open and close curly braces, because when you do this, a is equal to curly braces, open and close, and then you print this a, that's going to again print this opening and closing of this curly braces, but you may think that this is a set. But the critical thing here is, if you check the data type of this a, it's going to say it belongs to the class dictionary. So we know that dictionary also starts and ends with the curly braces, right? So when you just initiate something with this opening and closing of curly brackets or curly braces, it's not considered as a set, but it is considered as a dictionary. So it just creates an empty dictionary and not a empty set. Now let's say that we want to create a empty set. So what we can do in that case, so you can just, let's say the variable is called empty set. Again, the variable can be anything, it's not big deal. You can say set of, just open and close your parenthesis, just like the set method that we have used, but don't mention anything within the set method. And now let's print our empty set, and let's see how this looks like, and also print the data type of this you know empty set. Print this. So now it says set, this is the empty set that we have created, it belongs to the class set. So this is how you can create an empty set. I'll also put the code to create dictionary as well. Let's call this empty dictionary so that the distinction is clear. So empty dictionary is equal to open and close your parenthesis, sorry, curly braces, print this empty dictionary, and also print the data type, so that you can understand that you cannot use opening and closing of curly braces if you want to create a empty set. So this is like one distinction. So we have this set that has been created using the set method, and then we have created an empty dictionary using just like opening and closing of curly braces. So about dictionary we will discuss in detail, because dictionary is like one of the widely used data types. Like I would say that list and dictionary are the ones that we often use compared to, let's say, a tuple or a set. So these are also used, but most predominantly I would say, like in most places in your code, list and dictionaries are like used. So it's important that we understand that. So let's get to that probably in the next video about dictionaries. So this is about creating an empty set. So now let's understand about some of the set characteristics that would come in handy when we are working on some use cases in our code. So here I'm creating a text cell and calling this as set characteristics. So this is the fourth example. So I'll say one is duplicates are removed, right? So this we have discussed already in this particular section itself, but let's do that again. Let's say that A is a set that we are creating and it has the values like 1, 2, comma 2, 3, 4, and 5. So these are the, let's say, 6 values that we have in this set. But as you can see, 2 is repeated here. So it's a duplicate value, right? So this particular value is removed. So when you print this, print A, the duplicate 2 value has been removed. So this is like one of the characteristics of set. So the next thing that we are going to understand is, how you can also some simple operations that we can do with it. How you can add elements. And the thing about set is that sets are mutable. That means once you have created a set, you can alter the values. You can add values, edit values, change values, and so on, right? Just like a list. Whereas a tuple is an immutable sequence data types where you cannot change a value of a tuple once you have created it. So that's why we call that immutable. But sets are mutable, so you can edit those values. Let's understand that. So the next thing that we can do is adding elements to a set. So let's say that I have a set called as my set, or I can just like use a simple variable like k and say it has values 1, 2, and 3. Okay. So now I'm going to add a new value to this. Maybe first I'll print this a and then say a dot add, which is basically a set dot add. So this, you should use this add only with a set data type. So this is a set data type, so we can use this add method, and within this add I can, let's say, put some values like 5 and then print this a. So that's going to add this value 5 to the set that we have created. So this is how you can add new element to a set by using this add method. So create a set and use this add and mention like whatever value that you want to add in that set to add that element. So this is just adding one element, right? So what if you want to add multiple elements? Let's say that you have a list that has like some set of numbers and you want to add all those things. Let's see how we can do that. So here I'll say adding multiple elements to a set. So for this I can say, again, let's say A is the set that we are considering. It has the values like 1, 2, and 3. And now I'm going to say, maybe let's also print A first. And in the next step, I'm going to say A dot update, and I'm going to add a list to this. 1, 2, 3 is there, so I'll add 4, 5, and 6 to this. And finally, we can print this A. So now we have the original set, which is A, and that has the values 1, 2, 3. And now this A has been updated with 1, 2, 3, 4, 5, and 6. And the key thing here is you're not creating a copy of A, right? We are just like editing the original set that we have created, which is stored in this A. So that's why we call this as a mutable data type. So this is how you can add single element using add method and add multiple elements using the update method in set. So the next thing that we are going to discuss is how you can remove an element, you know, from a set. So let's say that we have a set that has like, let's say, 5 or 6 values, and how you can remove those values. So again, let's say that we have 3 values. Maybe I'll just take 5 values. So A is equal to 1, 2, 3, 4, and 5. So these are the 5 values that I have. So I can say a dot remove and mention the value that I want to remove. So let's say that I want to remove 2 from this. So I'll mention 2 and then let's print this a. So that's going to remove the 2 from the set A that we have created. You can also print the original set first and then like remove it. So first we have 1, 2, 3, 4, and 5, and we have removed this 2 using this remove method, and now that 2 is not there anymore. So this is how you can remove the elements. And there is also another interesting way to remove elements, and this is like a, I would say, a safe method. So that is about discard. discard elements. And the thing about discard is that, let's say we want to remove 2, but if 2 is not there in the set, it's not going to throw you any errors. But in the case of this remove, right? So let's say that I want to remove 10, but 10 is not there in the list. So it says that key error and that value is not present. So I'll change this back to, let's say, 2 or something, and that would just do that. So if that value that you want to remove is not present in the set, you would get a error. And in some cases, this is not feasible because you want to, this is just like making sure that that value is not present, and there is, let's say, a chance that that value is not there, right? So let's say that there is a large set that has like a several number of values in it. You want to make sure that the value 100 is not present in it, but also you don't want to, you know, um, get any errors if 100 is not there. In that case, you can use this discard method. So here I'll say, uh, let's work with the same a example. So I have this a is equal to 1 3 1 2 3 4 and 5, and I'll say a dot discard 10 and print this a. So of course we know that 10 is not there in this set because it has only the values from 1 to 5. And when you run this, it's not going to discard anything. So this we are printing it from line number 6. So discard won't print anything, but we are just printing it there. But the key thing is, even if that number is not there, it's going to ignore that. But let's say that we are discarding 5. So that 5 is removed, right? Even if in the second case when it's not there, it's not going to give you any errors. That's the distinction between remove and discard, which is like a, I would say, a safe way to do this delete operations. And in the next step, let's discuss about set operations. So I hope, I mean, like every one of us have learned set in our high schools, right? So we would have this set union, set interactions, and so on. So we can perform those operations in Python as well. So first thing that we can discuss is union. So what union means is it combines the elements from two sets without any duplicates. So let's say that we have a set A. So this is how we would write, right? So some uppercase letters, but again, you can definitely use lowercase letters as well. Let me use this one. So I'll say 1, 2, and 3. So these are the three values that I have in set A, and set B as the values of 3, 4, and 5. And I want to do a union. So union means like I have to join these two sets, and for this I can, let's say I'll call this union set. Union set is equal to, you have to say A dot union B. So A would be the first set, and to that first set this B would be united, and I can say print union set. It's going to give you the values as 1 2 3 4 and 5. And the main thing here is, when you join these two things, 3 is like repeated. There is a duplicate of 3, so 1 3 will be removed, so you get the values as 1 2 3 4 and 5. So that's why I said that it combines elements from two sets without any duplicates in the final union set. So this is one example, and I'll maybe copy this entire thing and paste it again. So the next set operation that we are going to discuss is intersection. So intersection is going to provide you, again, the other thing is like when you do this union, the output is also a set, as you can see here, similar to this in this case as well. In the case of intersection, it's going to give you a set as the final output as well. But what this would do is finds a common element, or I can say find common elements between two sets. If there are like two common elements, like those two elements are also identified. So in this case, the common element is 3, right? So the final output that we are expecting is 3. So for this, you can replace this union with intersection. So I can say A dot intersection of B. So maybe I'll call this as C for simplicity. And I would get the value as 3 because 3 is the common value in these two cases. The other example is the difference. Let me copy this and paste it over here and call this difference. And so we have a 1 2 3, and then we have 3 4 and 5. So what this difference would do is, these are the elements in set A but not in set B. So this is about it. So when you say set in, elements in A but not in B. So you have 1, 2, 3 in 1 and 2 are present in A but they are not present in B. 3 is present in A but it's also present in B. So the output that we would get in this case is 1 and 2. And this can be created with saying A dot difference. So if you want to do this alternate way, you can just say B dot difference of A. So that's possible as well. So when I run this, I get the values as 1 and 2. So if you put this B and then let's say A, so that would be the elements present in B but not in A. So that would be 4 and 5. So that's how you would get this. But let me replace this. So that's about the difference. EMC. Okay. So elements present in the first set but not in the second set. And there is another symmetric difference. Let's say that you want all the elements that are not common, right? So you got 1 and 2 in the first case, but when I replace with B and A, we got 4 and 5, right? But how to get these two things? So that's about 12th one is symmetric difference. So here I can again create the same thing, and instead of this difference I can say symmetric difference, A dot symmetric difference, and you would get the values as there's a dot here, 1, 2, 4 and 5. So all the elements present in A and B but not in both. So how this can be explained is like uh, elements present in either A or B, not both. Okay, so it should be present either in A or B, but it should not be present in both cases, which is 3 in this case. So you would discard 3 and print like all the other elements within a set. So 1, 2, 4 and 5. So these are some of the interesting operations that we can try. There are like few other operations that you can explore, but just as a starter, like these are enough to get you started, but explore other things if you want to understand more about this. And the final thing that I want to explain you about, like another data type that is related to this set, or I can say this is like a variation of this set, and that is a frozen set. So I'll make this a markdown, and here I'll say, you know frozen set. So frozen set, again, it is also a set, but it's like a immutable version of set, right? So you can just think about this like it's a tuple but for sets. So we know that list and tuple are similar, only the difference is that tuples are immutable. Similarly, the difference between set and frozen set is that sets are immutable, but frozen set, sorry, I made a mistake. So set are mutable, whereas frozen set are sorry, I think I'm missing this again. So sets are mutable. That means you can change the values that's present in a set. Whereas in the case of frozen set, as the name suggests, the set is frozen. You cannot change the value. So this would become an immutable data type. So let's say that I'm creating a variable called as A, which is equal to, you can use the frozen set keyword and say the values like 1, 2, 3, 4 and 5, right? And then print A and also print the data type of this A, and this would say that this is a frozen set 1, 2, 3, 4 and 5, and it belongs to the class frozen set. Now previously we have seen that we can add elements to a set by using this add method, right? So let's try that same thing. So I'm doing this, I'm printing all this thing, and then I'm saying uh, a dot add value 6 to this. When I run this, I get a error saying frozen set object has no attribute add. So this is how you cannot add elements to a frozen set, and that's the difference between a set and a frozen set. Not just add, but you cannot edit those values, so it becomes an immutable data type. So whenever you want to have set, but also make sure that this set is not changed, the set values are not changed throughout your code. Let's say you want to make this immutable, you can go with a frozen set. So I hope everyone is clear about the topics that we have discussed. So please try this code, and it would definitely help in the long term when you're like working with larger Python use cases and so on. So that is all from my side for this video, and I'll see you in the next upload. Thanks for watching. Hello everyone, I'm Siddharthan. This is the 19th topic in our complete Python course, where we will be discussing about dictionaries. Dictionaries are a very important data type in Python, and we use it in a lot of places when you're doing a Python code. So in this video, let's try to understand how we can, create a dictionary, access the data points in a dictionary, and just like a lot of operations that we have in it. So this will be the agenda for today's video, and let's get started. So for this coding, I'll be using Jupyter Notebook, but you can use any other notebooks or IDEs. So in this, first I'll create a markdown cell and I'll just put a text here saying creating dictionary. So this is the first thing that we'll be discussing, creating a dictionary. Okay, so there are like two ways that we can use here. The first one is, you know, using a curly braces. So I can say my underscore dictionary is equal to, so you start with curly braces, and let's say you want to have a empty dictionary and later add values in it, you can just like simply create it using this curly braces, opening and close. So in the previous section we have discussed about sets, and set also has like these curly braces, but if you initiate it with opening and closing curly braces, it represents a dictionary and not a set. So we have seen that already, but this is how you can create a empty dictionary. So you can copy and paste it over here to print and see its content, and also make sure that the data type is proper using the type keyword that we have in Python. So this is going to print my empty dictionary that has only the opening and closing curly braces, to which you can later add values in it, key values and key and value pairs in it. And we know that dictionaries are mutable data types. So this is also something that we have discussed in the previous sections. So dictionaries are, mutable. That means you can modify, delete, or change values present in a dictionary after you have created them, compared to, let's say a tuple, which is a immutable data type in which you cannot change the values of a original tuple, but dictionaries are mutable. So this is how you can create a, empty dictionary. Now I'll just create another simple variable as, let's say, a, and in this I'm going to put some key value pairs, and we know that dictionaries are kind of a key value pair data types. So you have a key and a value associated to it. So the key can be integers or strings. So it's not that it should always be strings. It can also have integers that we will see in the later part of this video. So in this case, I'll say a is equal to name, and I'll put a colon and say John Doe. Okay, so this is how you can create a key value pair. So first you mention the key and you put a colon, and then you put the value in it. So you can put a comma and say, let's say the second key is age, and let's say age is 30. So you can have integers or like basically any data type. So in this case we add string as the name's value. So the value of this key name is a string value, which is John Doe, but for age key it is an integer value, right? And then let's say we have something like a city, and city is, let's say, New York. Okay, so these are the three key value pairs that we have in a dictionary. Now I can say print a, and also maybe print type of a. So that's going to print the data type. So that's going to say it is a class dict. That means it belongs to the class dict, which is dictionaries. So I can say type A. So it's going to print your key value pairs. So the other way to do this is you don't have to put all these things in a single line. So you can also introduce a new line over here. So you can see the indentation that it has automatically created. So you can move to the next line after this comma. So that's going to do something like this. So we have name John Doe, age 30, and city New York. So we would have the values like this. So this is also like how you can create key value pairs. Again, nothing different from these two. Only thing is that we have one key value pairs in one line, and this is how you can infer this. So first you have a key colon separated by the value that you want to associate with it. Put a comma. So this would be the first key value pair of my dictionary. This is the second key value pair, and third key value pair, and so on. So this is one way to create a dictionary by using the curly braces, right? And the next way is, using dict function. So this dict, which stands for dictionary, is an inbuilt Python keyword or an inbuilt Python function. So I can say B is, let's say, the dictionary that we are creating. In this case I can say dict. You can see the color of this word changed to green, so that means it's a Python keyword. And I can say name is equal to John, and age is equal to 35 or 40, something like that, and comma, mention, let's say, city is equal to New York, right? So these are the three values that we have, and now I can print my B also the type of B. So what's the data type of B? So we can verify that as well. So this also creates a similar key value pair dictionary. Only difference is that we have used this dict method where this represents the key that you want to create. So name is the key, age is the key, and city is the key. But you put a equal to sign. So when you're creating this within a curly braces, you mention this as colon, but this is like using a function and using like this parameter kind of a thing. So the parameter or this basically represents a key and is equal to, you put a value there. So this becomes the key of the dictionary and this becomes the value of the dictionary that you're creating. So name, age and city would become my key, and John 40 and New York would become my value as we are seeing there. So this is how you can create dictionaries. So one is using this curly braces method, the other one is like using the Python keyword dict method. So these are the ways to do this. So let's say that now we have successfully created a dictionary. So now we can access the values present in the dictionary. Like let's say we have John, 40, age is 40, New York, and so on, right? So you can access these things. So I'll create another text cell and I'll call this as accessing dictionary elements. Okay, so this is the next topic. So there are like two ways to do this. One is using the key. So using a key you can access a value. So I can say print, maybe let's first create a dictionary like this, or I'll copy this one. Let's say A is the dictionary. Let's put this in a separate cell. We can refer to this in the next cells. So A is the dictionary. We are going to work with that. So let's say that I want to print the age value. So age is the key. I want to print this value which is 30. So I can say A of uh, put a double quote as this is this key is a string data type basically, and now run this. So this is going to print your value. So when you say A of age, that's going to print the key that's present in that dictionary. So if you want to print the city, it's just like similar thing. So you put a and let's say city, right? So when you mention something for which there is no key, let's say I'm putting a value as, oh sorry, a key as country, so that's going to say a key error. That means uh, you know this key is not present in this dictionary. Okay, so this is about that. So accessing the value of a dictionary using its key. And the next one is using the get method. So using get method, I can say print a of, or I can say a dot get, put a parenthesis and say let's say city. So this is going to again do the same thing, but instead of accessing this using this way, we are just like using a function called as get to print that. So next thing that I'm going to do is, let's say, get the age value. So that's going to say New York and 30. Okay, so this is how you can access the values of a dictionary using its keys. So first we have just used the keys, and the next one is just like using this get method. So that's about it. So the next topic that we can discuss is about the mutability of dictionary, that is, let's say, modifying a dictionary. So I'll again you know put this a dictionary. I mean, we don't have to do this because this a would still be there, but just for simplicity I'll just like mention this so that you can quickly see what's present in the dictionary. So now let's see how you can add a new key value pair. So you cannot just add a key and not a value, or just like simply add a value to it. So key and value comes in a pair. So let's see how we can add that. So add a new key value pair to an existing dictionary. So I can say a double quotes country. So mention the key that you want to add in this double quotes within the square bracket, and say like what's the value that you want. It can be a string, integer, or like any data type. So this is how you can add this. So you say a country is equal to USA, and finally you can print your a. So before, I mean, here also you can print your a and see that the key value pair. So it didn't add this country key. So now I'm adding this as USA, and now I have another key value pair called as country and USA. Now let's say that we want to update the existing key value pair. Let's say I want to edit this age to 40, 30 to 40. In that case, what you can do is, again, it's similar to what we have done here. So I can say So updating an existing value. So for this I can say a double quotes age is equal to 40. So that's going to update this print a. So that's going to update this value to 40. Okay. So this is how we can update the values that's present in a dictionary. And the other main thing is a dictionary cannot have two keys that are the same. So you cannot have two key value pairs with the same key. So let's say that you cannot have name as John Doe and another key value pair as name as some other name or the same name. So that's not possible. So if I just like try to add a key value pair, something like name is equal to, I'm saying Jane Doe, this is not going to add a new key value pair because these keys are like unique in a dictionary. So this is instead going to update this key value pair. So I'm going to say print a. So this has been updated. So this is like kind of the same when you do this kind of a creation. So let's say that I'm saying this A is John Doe, age 30, city and New York. But let's say that I have another key value pair with the same key, that is name, and say it's Jane Doe. So it's not going to create two keys with the same name, that is name. Instead, it's going to have this Jane Doe as the name, right? So this is like a very important thing to note. So you cannot have duplicate keys in your dictionaries. Only like one key can be used, and when you put multiple things, the latest one will be kind of the one that's like finally there. So this is about modifying the values present in a dictionary. And now let's see how we could remove the key value pairs in a dictionary. So I'll create a markdown here and say removing the elements from a dictionary. Okay. So for this, you can use the delete method. So del, again, it's a Python keyword. So I can say delete. Let's maybe create this a again, or I'll use this one instead. And let's print this as well. Okay, so this is the dictionary, that is a. So from this, again, you can use the key. I can say delete city. So city of 8. So whenever you are mentioning this key, you should put a square bracket and mention that in quotes. If it's a string, you can mention it quotes. Otherwise, you can just mention it as it is, like if it's an index, right? So I'll print this A. Oh, sorry, I missed this square bracket. Oh, sorry. Okay. So now, as you can see, the city key has been removed. Okay. So this is how you can remove the elements or basically the key value pairs that's present in a dictionary. And this is again using the delete method, and there is another method, and this is like kind of, there is another use for this method that we are going to discuss, that is like pop method. So for this I can say age is equal to, or yeah, maybe let's have this age. So let me create this again so that it's clear. Let's say that this is the original dictionary that we have. Let me create this again so that we have all the key value pairs that was originally present. So we have name, age and city, right? So we know that. So now I'm going to create a variable called as age and say age is equal to a dot pop, that is the dictionary name. So the dictionary name is a, so say a dot pop, put the name of the key, that is let's say age, and now print your a and then print your age. Or you can, this value can be anything, maybe let's not put this the same name so that it's making sense. This is how you can pop a value from its key value pair, but or basically remove that key value pair, but also store that value in a particular variable. So here basically we are removing this value 30, but we are storing this in a variable called as 6. So now my dictionary has been updated, but also I kind of saved that deleted value as well. So this is how you can use the the pop method. Whereas delete method just like delete the values, but this would like store the values that's present in it. So that's like another example. So the next thing that we can discuss is keys, values, and yeah, basically how you can access keys and values. Let's say this is the fifth example, right? It's the fifth one. So I'll again use the same dictionary A. You can print it if you want. So now let's say that we want to extract all the keys alone. So in order to do that, you can say create a variable. Again, this can be keys, or you can name this variable anything. This is a variable, so the name doesn't matter at all. So I can say a dot keys and put a parenthesis, open and close this, and now print your keys. So that's going to print all the keys that's present in your dictionary. So using this keys method and saying dictionary dot keys. So a is nothing but the dictionary that we have created. So it's going to print this. Now I'll copy this, replace this keys with values, and that's going to print all my values. So if you want to print or basically extract all the keys that's present in a dictionary, you can use this a dot keys. If you want to extract all the values, you can use this values method. Okay, and that's about this key and values. Now let's see how you can iterate over a dictionary using a for loop. Looping uh, through a dictionary. Okay, so this is the next thing. So I can say for key in a. Again, let's take this a. Let's put this a in this cell as well. Print key. So when you iterate over a dictionary, it's going to iterate over the keys. That means when you run this key variable, when the for loop runs for the first time, it's going to take the value of this name. And the second time, it's going to take the value of age. Third time, it's going to take the value of city. So the main thing to note here is when you iterate over a dictionary, the variable that you have here won't take the values, but instead it will take the keys. So maybe let's not use this key so that it's not confusing. So I can say for I in a, print I. So that's going to print the keys. So whenever you're iterating, you can remember that it's going to iterate over your keys. So now let's say that you want to do the same thing. So here we have printed all the keys individually using a for loop, but how you can iterate over a dictionary and print all the values that's present in it, just similar to what we have done here, just getting all the values and keys and all that, but just using a for loop. So I can say a is my dictionary and say for key in a, print a of key. Okay, so this key shouldn't be present within quotes. So what basically we are doing is it's just like this accessing thing that we have seen. So here we know that we can access the dictionary values using the key, right? So if the a is a dictionary, you can say a of age. That's the exact same thing that we are doing, but just we are doing that in a for loop so that we can print all the keys, sorry, all the values present in it. So when I say for key in a, for the first time, this key is going to take the value as name, and we are saying that a of name, so that's going to print this. Second time, this value of this key would be age, and we would say a of age, so that's 30, New York, and so on. So when you print this, that's going to print your key, sorry, not the key but the values that's present in it. So now let's say you want to print this key and value side by side. So I can say a is this thing, and then I can say something like for key, and for key in a, I can print my key, or maybe we can use a f string, so that's so that we can just like use that one. So f string is basically for substituting some variable. So we have discussed this in the print and strings video. So if you want, you can refer to that as well. So I'll say something like this. So first I want to print the key, and value would be a of, which is in single quotes as we already have double quotes outside the string. So I can say, sorry, I can just say key. Okay, so that's going to do something like this. So again, it's just the same thing that we have done here. Only thing is that along with this a of key, that we are printing here, we are also printing the key, just putting this in a f string so that we can have like both of these things together. And f string is, we know that it's used to substitute some variables in a string. So when you use this f string, you put a curly braces, and when you say key, so this key will be replaced with this variable value, and this would be like replaced with that corresponding value, and so on. So this is how you can do some stuff with this for loop. And again, there are like a lot of things that you can do. Like if, let's say that you have all the values as some integer values, you can take that, multiply that, and then like append that to the dictionary. So you can just like try a few things like that. And the other thing is like that we can discuss is dictionary comprehension. So we have discussed about list comprehension, where you can create a list in a single line of code using a for loop. So this is similar to that. So I can say dictionary comprehension. And I've told you, right, so it's not like only the strings has to be the keys. So the key of dictionary can also be an integer value. So I can say, let's say A is my dictionary that I'm creating. I can say x colon x asterisk of 2. So that means square root of 2 for x in range 10. And print this, oh, sorry, this should be present within curly braces as this is a dictionary. And run this. So what we are doing is we are creating again a key value pair. So key is a number and value is the square of that number. So we have 0, square of 0 is 0, we know that. So square of 1 is 1, square of 2 is 4, 3 is 9, 4 is 16, and so on. So how we are doing this is we are iterating this over this range of 10. So we know that when we say range of 10, it's going to start with 0 and end with 9, right? Because when you put range of 10, it's not going to include that 10. So it's between 0 and 9, or basically 0 till 9 but not 10, right? So it would iterate over this, and at each time x would take. So for the first time when this for loop runs, x takes the value 0, the next time it takes the value 1, 2, and so on. So let's say for the first time it takes the value as 0. Now we have a curly braces, so that's going to create a dictionary, and we are saying x colon. So that means this x that we have over here, it's going to act as a key. And the value for this, as we have a colon here, the value is x asterisk asterisk of 2, which is nothing but square of 2, sorry, square of x, right? So when you put x asterisk, double asterisk sign is like power or exponent, so it's x exponent 2. So for the first time x takes the value 0, so you would say 0 colon 0 asterisk 2. So this would look something like this. So when it runs for the first time, we would say like create a dictionary that has values like 0 colon 0 power 2. So the second time it would append this thing to that. So it would look something like this: 1 colon 1 asterisk asterisk 2, again which is 1, and so on. So that's how you create a key with the value and sorry, with the key as the 0, and this value is nothing but the square of that, and so on. So this is what we call as a dictionary comprehension. Again, if you want the value should to be the same number, you can just like use this x colon x, so that's going to have the same values. If you want to put like cube of that number, you can just use this one. Oh sorry, you cannot have the cube like that, right? Sorry. Yeah, so you can do this. So cube of a particular number, so I'm saying like 3, so it's x power 3. So we have 1, so we know that 2 power 3 is 8, 3 power 3 is 27, and so on. So this is how we can use dictionary comprehension to create dictionaries, uh, you know just using a for loop and create it in a single line. And the next thing that we are going to discuss is merging two dictionaries. So this is the last thing that we would discuss. Let's say that we have two dictionaries. So A is something like this. Name is John, and age is 30. And let's say B is city. City is, let's say, New York. And next we have, let's say, country is USA. Okay, so these are the two dictionaries that you have. Now you want to merge these two dictionaries. So there are like two ways to do this. So first is, say, using update method. So I can say a dot update. So this is going to update the original a dictionary. So a dot update b, and now you can print this a. So now we can see that originally a dictionary has the key value as name and age, and now we have added this city and country to that as well. So this is how you can merge two dictionaries, but by altering the original dictionary that we have created. But if you just print your b, it would still be just like city and country. So we are just like updating this a with this particular thing. But let's say that you want to merge these two dictionaries, but you don't want to change the two dictionaries that you have. So for that you can use a different method, but this would work only from Python version 3.9. So it works on like Python 3.9 plus. So the previous version may not, like we may, this may not work. So let's say that we have two dictionaries a and b with certain key value pairs in it. So I can say I'm creating a new variable called as merged dictionaries, or merged dictionary is equal to, so put a curly braces, mention to asterisk sign and a comma double asterisk sign b, and print your merged dictionaries. So that's going to do the same thing, but this original dictionaries shouldn't be affected. Let's check that once. Right, so the original dictionaries has not been affected. So if you want to put the b dictionaries values first, you can do this. So first you have the b dictionaries key value pairs, and then you have a value. So we have city, New York, country, USA, name and job. So this is how you can merge two dictionaries. So these are the things that I wanted to discuss for dictionaries. And again, these are like pretty simple stuff, and there are like few more things that you can explore as well. But these things should be good, like when you're like starting to work. And maybe the other thing that I can leave you with at last is, maybe I'll include this as well. The ninth one is a next nested dictionary. So I can say you can have a dictionary within a dictionary, or like multiple dictionaries within a dictionary. So it would like look something like this. I'll call this as nested dictionary is equal to, I'll open a curly braces, say John. John is the key of this dictionary, not the value but the key. Note this. So in this case John is the value, key is the name. So here John is the key, and I'm saying uh, age is 30 and city is New York. Okay. So similarly put a comma over here, copy this entire thing, come to the next line, but now change this to, let's say, Jane. Age is, let's say, 35. City can be the same or different, so this doesn't matter, the values doesn't matter, right? So this can be, let's say, California, something like this. Not sure if California is a city or something, but that's okay. So now I'll print this nested dictionary. Let's run this. Okay, so here we have created a nested dictionary where we have a key, but the value associated with this key is again a dictionary, right? In this case as well. So this is a key and this is a dictionary. So this is how you can have nested dictionary, which is nothing but dictionary within a dictionary. And this is also like useful in some cases, and in a lot of data, when you're accessing with some data, there are chances that you have like multiple such steps. So you have a key and then you have a dictionary, and within this you have, let's say, another dictionary, and within that there is another dictionary. There are like several steps of nested things are possible as well. So this is like an interesting thing to note. And uh, we also work with JSON, which is like pretty much similar to this dictionary data type. So you would have this JSON file, we would load that, convert it to a dictionary and so on. Maybe let's come to that later, but that's other thing to look out for. So we usually read a JSON data and convert it to a dictionary. Yeah, let's get to that data, but I just wanted to give you an heads up. So these are the things that I wanted to discuss today. So we have started with creating a dictionary, like with a couple of methods, and we have also seen how you can access the values in a dictionary using its keys, and how to modify a dictionary as it is a mutable data type. And then we have discussed about removing elements using delete and pop method, and how to access like all the keys and all the values. And main thing is like how to loop through a dictionary using a for loop. So this is something that you can try a lot more, like doing like a lot more stuff than what we have discussed today with the for loop and the dictionary. So this is something that we often do. And then you have dictionary comprehension, basically to create a dictionary and then merging two dictionaries and finally creating nested dictionary. So I hope you have understood all the things that we have covered today. So please go through all this code and please practice this. So that's definitely going to help. So that's all from my side, and I'll see you in the next upload. Thanks for watching.